Okay, my latest eBay purchase has arrived. It's a signal generator, a Fluke 6060B, 10 kHz to 1. Well, just over gigahertz. So apparently has a fault. I don't remember what it was now. I think it was slightly off frequency or something like that. I don't remember. Anyway, so I haven't powered up yet. In the back of it is this little board here, and it's quite a cool little jumper system actually. It got slots in the back, and you just pull it out, turn it around, put it back in again for the voltage. So instead of having a switch, you just got a little PCB, which is quite an interesting method of doing it. I haven't come across that particular way of doing it before, I think. I don't know, I'll see it somewhere else. Can't think where though, but yeah. So it's got a 240 volt, that's what our nominal voltage is here. Well, at least here I'll get 240 volt all the time, it's supposed to be 220 I think, so anyway. So I'm going to slot that in, then we'll try powering it up. Okay, so this is where it goes in. Here's the card, 240 volt set, and there's a little slot just in the bottom there underneath the fuse, and it pops in there. Let's just try and get it in. It's quite a tight fit. Obviously it's got some decent spring terminals on there. So it's got a nice good contact. There you go, that's in, and you can see 240 volts, that's correctly set. Right, let's power it up. Actually I might just go and check and see what was wrong with it first, then I'll power it up. Okay, moment of truth. Dodgy power button. Fan works, display works, although that looks a little bit dim. Okay. Power button's dodgy, obviously. Okay. Yes, this power button's going to drive me nuts. That was mentioned in the listing. Okay. Well, it's on now, but that wasn't mentioned. Well, apparently it's doing 1 gigahertz. Right. I've got no idea to use this. I haven't read the manuals or anything yet. No idea. Let's have a guess, eh? 50 megahertz. Oh, millivolts. I guess I need to tell it which function I'm doing. Frequency. Here we go. Let's do 26.33 megahertz. Okay. Nothing coming out. AM modulation 30%. Okay. Going to, isn't it? Into an AM, okay. See, I really should read the manuals and figure out these things anyway, but let's see. So I want to come to, how do I do this one? Aperture, here we go. 11 dBm, really? Okay. Microvolts. Right. 1 volt. My monitoring radio isn't receiving anything, so I'll have to hook up to the back and see what's actually coming out of it. Okay, I've hooked up the back, and I've set the frequency, and the radio's getting it. But listen to that awful noise, and that's the modulation turned off. I had the modulation, hear it. 400. So there's a big buzzing sound coming through the audio, which is interesting. Yeah, that's going to make things a bit of a problem, I think. I can't measure the frequency, the output is not high enough at the moment. Let's go. Can't do 5 volt, 3 volt, 2 volt. Okay, so it is actually generating the right frequency, but it's got that buzzing sound, so it could be a power supply problem going on here. So let's shut it off. Yes, that buzzing was awful. Right, so it must be a power supply problem at first guess. Sounds like AC is getting through into the DC section, so I'll kind of pull this apart and do some measurements and stuff. Go from here. Okay, top cover's off, and amazingly, the top of it is basically empty. There's like nothing in it. They could have made this case half a size. So that's also the crystal oscillator, oven unit, power supply units. Those look okay. These capacitors, they've got these plastic domes on them, but that I can actually feel this bulging. That feels okay. That's bulging. I can't feel the other ones too down. So looks like I'm just going to have to recap some of the power supply, which is based on the buzzing, so I was expecting. A little bit of dust in there, but nothing too unusual. Fan was okay, but a bit noisy. Looks like someone's pulled the cover off that and lubricated at some point. Oh, that plug there's not on very well. See that plug that's there? Get some lighting a bit better. Oh, right. There we go. So the plug's not pushed on properly. May or may not matter. It's just, there you go. Could have shifted during transport. Got some tantalum caps on there. I have to check all those. I don't trust tantalums. So we've got this board down here, whatever that is. A little bit dusty, but otherwise, don't look too bad. I probably have to go through and get a bit of a clean. There's a few little inductors and stuff on there, and all looks okay. What's it say? Relay driver. Okay, right. And there's the power button on the back there. Just there. So I might pull that apart, or pull the insulation off it and try and spray some cleaner in there and see if I can free it up, because it was not latching properly. It might just be it needs a good clean. Hopefully we'll clean that up and it'll be right again. Right, so a whole bunch of filters along here on the AC line, looks like. Yeah. Oh, that's an RF line through there. That's a coax. That's a solid coax going through there. So that must be the for the rear output option, which is a shame. I was hoping it'd be easier to move it than that, because I wanted to put it back on the front. That's going to be tricky. Alright. So I guess I'm going to have to pull the other half apart. I'm going to pull all these screws out. But that's what I think the problem is going to be, is in there. Okay, so I've got the bottom cover off now. There's a GPIB board stuffed in there. A couple of little IF connections here. Go up to here. So I've got push on ones, they feel like they're fine, they're pushed on okay. Here's the other capacitor I was trying to fill, and it feels like it's got a it feels okay. I'm pushing that plastic cup and it goes down, so I think maybe they don't all need doing. This one here does need doing, so you know, if they're bulged out, I'm going to have to change them basically. There's a plug in here, it feels okay. So yeah, I mean, really, if you look at this thing, there's so much wasted space in it. They could have actually made the thing a lot smaller. Anyway, could have made it half the height, or stacked the boards and made it half the depth. Would have been better. But so this sort of power supply's got to come out. I've got to figure that piece out, and I probably will do voltage measurements on it first, actually, to be sure, just to test what before and after. Okay, it's just seem to have got this switch working properly now. seems okay. What I've done, there's a little grey wire down here. Just coming right at the back there, can't really see it. Just there. And the actual mechanism, the little lever there, which does the toggling for the activation and sort of match the switches in there. You see it moving. That was just touching that wire, so it could be that it wasn't actually able to move properly to latch. So hopefully that's it. Okay, I'll give it a bit of a clean as well. So hopefully resolve that problem. So I'll need to figure out how to get this power supply out at some point. But I'll say I'll do voltage test first. Now I've got that switch sorted out, it should power up a bit better. Right, so I pulled the ovenised oscillator out. The wires were grey, black and then yellow in order across here. Just for reference. It looks like someone's already had this out at some point. The wires, the soldering wasn't great on them, and the insulation was slightly melted. So I suspect they actually had a problem with it. So I'll come over here, and this is the actual case. And it looks like it's been opened up because it's got lever marks on it. So someone's already had a go at this. This oscillator's not working. It's not heating. So the oscillator itself is running, but it was not heating up. So I've already had a little play around with it, as you can see. And I'll just hooked up. Runs 23 volts and 5 volts on there. And that side there is the output. I'm not sure what this one is. That side there is. I'm not sure what that is. I haven't actually looked at that yet. But say it wasn't heating up at all. I took it out. Inside here is the actual oven unit. Let's just open this up. Oh my god! Hold on, let's get the tripod out. This is ridiculous. Let me get the tripod. This will make things a little bit easier. Okay. Okay, tripod. Right. That's better. Now, so inside here is the actual things. You can see it's been taped up really roughly. So I'll just peel that off. And there's the oven. Nothing there. It's just some insulation. And I've given it a little bit of a clean up, just very roughly, because it's covered in dead foam. On here there's a little adjustment here, which would be, I believe, is the oven temperature. And so it wasn't heating at all. This was not warming up. See, it's got like a resistance wire around this body here to create a thermal mass. And the course adjustment for the frequency is in there. There's another little adjustment there. I'm not sure what that's for. Anyway, the thermistor is here, or thermocouple, whatever the hell it is on there. But it's mounted right there, and it all seems okay. I don't believe there's an issue with it. But anyway, what happened is I gave this, I sprayed some IPA all over this cleaner here to try and get some into it, and turned it a lot, and it started to heat. But its operation seems erratic. I'm not quite sure if it's just that it's got a really long stabilisation time, or whether it's actually still got some kind of fault where it's not properly heating. Whether it's this trimmer or whether it's something else, I'm not sure. I actually want to maybe just replace this. So what my plan is to put it back together, well, back into its insulation, stick a thermocouple onto it, and measure the temperature of the oven, and get it up to, say, well, I think probably between 50 and 80 degrees, I think, is what I've seen referenced for oven oscillators. This, when it kind of stabilised the best, it was so hot I couldn't touch the body. Right, so I'm thinking it's probably 80 degrees, not 50. 50 I can touch, 80 obviously not. So I think it's probably supposed to be really hot like that. Yeah, so I'm guessing this is to set the actual temperature it sits at. So what I want to do is actually run it, get it set to the right temperature and get it stabilised, and then what I'll actually do is I'll just measure the resistance across this thing and substitute, because I think this is dodgy and you can't really clean it. So I'm not sure if that's dodgy or not, but not 100% sure. As you see, it's got this dead foam all over the place. I'm tempted to try and strip it down. So it does oscillate, it does heat up now. I've messed with that trimmer. There may still be an issue there, but I'm tempted to strip it down, but also I don't want to break it if it is working now. There's a slightly dodgy looking joint just there, but just very slightly. So I don't know. I mean, it's got this heat sitting right next to all those components, so maybe there's something underneath there which is aged. This board here appears to be the output control board, so this is like shapes it into a square wave. That's my guess. It's also got the fine trimmer here as well for the frequency. But yeah, I haven't actually done any good component testing on these. The issue with this is that it wasn't heating, so that's just what I'm just dealing with right now. Yeah, so I'm going to carry on playing with this and I'll come back. So I also should have mentioned is how I got to that OCXO in the first place. In this section over here, this is a 10 megahertz crystal right there, and just spin around this way. Got it on the floor now, so I need the bench space. And let's zoom in a bit. This point here, that's where the OCXO feeds in through the hard coax, and it goes through this device here, which does switching and stuff like that. Just here, so just there is the 10 megahertz crystal. That's a trimmer for the crystal, and actually when I was switching between internal and external modulation at the test point, which is just there, you can probably barely see, just there, test point, I was getting different frequencies. So one was from the internal crystal oscillator, which when I set to internal. When I set to external, which should be getting a 10 megahertz input on the back, this one here was running. So obviously runs as well in case the external reference is missing, as like a backup. But this wouldn't trim the frequency either. So what I've actually just temporarily done, I'm guessing there's a surface mount part on the back or something. It seems to be a bit missing compared to what's on the in the service manual. There should be another capacitor, was it 180 PF or something, between this trimmer and the crystal, but there's nothing here. So I think it's on the bottom of the board. And the board is one big board with lots of stuff on it. I ain't taking it out unless I absolutely need to. So what I've actually done, I've just got a ceramic cap for the time being, and it's pushed between the earth and those reactor diodes there. It's only 10 PF, just to put a little bit of loading onto it, and that's actually allowed me to trim the crystal to 10 megahertz now. Before I couldn't trim it. The lowest I could trim it was about 10 point. I think it was about 40 hertz over or something, 50 hertz over. And that's actually doubled for the frequency output. So the here's 100 hertz out at the best. So anyway, doing that has allowed me to trim that crystal there. And that's when I found the OCXO frequency was wrong, and I couldn't adjust it. I couldn't get anywhere near close. It's still like 200 hertz out or something, 260 hertz out, and that's why I started investigating that and realised that it wasn't actually heating up. And once it heats up, it comes to temperature, and well, obviously, it comes to frequency, and then it's actually correct, or within trimming range. So once I get that OCXO sorted out, I'll be right. I might even replace it if I can't fix it. There's plenty of them on eBay and AliExpress and places like that, so it's very inexpensive just to replace the whole unit, and I'll probably get one smaller and fit it inside the same can with a little power supply or something, maybe just to work. So it's all used the same connections. Anyway, we'll see. Yeah, I've started to what's part of been trying to clean it. I've tried to resoldering all the board in case that is what was wrong, but that hasn't helped. So pulling this apart, there's a couple of screws, one there, and there's a through-hole pin just here, which is soldered underneath. And what I found is there's a second temperature probe there, there's one there, and there's obviously that one just there. So it's got two temperature probes, which is interesting. And look under here. Just bring this over a bit more. Now we have a PM741 CJ device, and otherwise there's not a lot going on there. This will be a heater as well, so it's got a heating element here, and I believe that'll be a heater there as well, just to help it a bit further. That's what I think it is. Let's see what I can see there. Okay. Just trying to tell where the heater elements go to. So that solder pin goes to the heating element. Yeah, I was trying to figure the circuit out. That's the 23 volt supply going through a diode. Let's just put this down so I can try and point it out. Right, so 23 volt supply comes in to this point here. That's negative, that's positive. Through that diode, so that's 22.8 volts here, and that's going onto that side of that winding. And it also feeds through resistor to that probe. Interesting. It also goes through capacity for smoothing and stuff like that. That goes to the negative. There's a positive voltage, as does this one here when it's on. Actually, it's positive when it's on the whole time. That's interesting. Okay, right, I know what they're doing. Okay, so you've got 24 volts coming in this pin here. Well, 22.8 volts. Passes through the coil, back through to here, to this device. That device, when it's not heating, is turned off. And so you're measuring 22 volts or so there. But what it does when it turns on, obviously it shunts it, tries to earth that, well, connected to 0 volts, which causes this device to heat up because it's switching, and heats the coil, so it's using that spare energy to heat as well, which is quite good. So none of the energy is actually being wasted. Yeah, so that's how that works. So that must be the gate. So that's I'm not sure. I don't know what this device is. I've got no idea. I'm not going to lift it up. I don't want to risk breaking it. So that must be the gate there. So when I've seen this thing heating, I was measuring 2 volts and 3 volts. I can't remember which pin it was on. Yeah, 2 volts and 3 volts I was measuring on either of those two pins. So I think this device is switching okay, but it's not being controlled properly. And the control is coming from this thing here. So I need to do some research on that device. I'll come back. Okay, I managed to figure out what that device is. It's a op-amp. The 741 probably should have given it away actually, because it's probably just a different package style. So there's the pin out for it. It's a little interesting. The package isn't quite exactly the same, but it's close. Yeah, well, it's there's very little information on them. I was lucky to find this data sheet, I think, but yeah, that's it there. So I'm going to have to look at this and see if the device itself checks out. Right, so I've decided to do some actual testing on this trimmer on here. You can see I've got my meter up here. I've got a set of resistance. Currently it's unpowered. Let's turn this off, get rid of the noise. Now I'm going to try and probe across the trimmer. This is a little bit awkward. Alright, now hopefully you can see what this, you can see what display is doing. Which I might change to, where's the rate? I've lost the rate. There it is. Fast rate. So we go through the trimmer range. So you should see it will be all nice and smooth. Oh, see it? It's a 5K trimmer. That's not right, is it? That's right at the end there. 50 odd K. That's not right. So you need to have some dead spots in that trimmer, see? Yeah, look at that. That's just 59 or whatever the hell that is. And if I go back the other way, it starts working. So yeah, that trimmer is what's the problem. I've got no idea what it should be set to. That's the only problem. Yeah, that obviously sets the temperature. What I'll do is I'll take it off, I'll run a separate little trimmer onto it, put it back into its cover, hook up a thermocouple, heat it up until it reads 80 degrees and starts controlling it, and then I'll go from there. And I'll probably replace it with some fixed resistors instead. Alright, so what I've done is I've pulled the little trimmer off, I've broken the side open, and the heat has actually got to it, it's all gone very brittle. And that's the adjustment there, see, it's just flapping around like it's broken inside. So that's what's wrong with it. This is stuffed. There's a little, you can see the track inside there, that runs across the track, runs up and down as threads, but yeah, it's not meant to be like that. So it needs a new one, definitely. Okay, so at least I found a problem with that. So unfortunately I don't have any multi-turn trimmers here. I do have this one, same value. I'll just have to see if I can actually put it on here somehow. I'm not sure how lucky I'm going to be with that, so I'll have a look at that and see if I can actually get it on there somehow. If I can, then great. Well, I've got the trimmer installed. I haven't cleaned the PCB yet, but it's installed on there. It's got one leg sticking off the side, but I'm not too worried about that part. I'll just cut that off or something if it works okay. So let's power it up and see what happens. Okay, it's heating. That's a good start. I need to turn my scope back on again so I can get my signal reading coming through. So unfortunately I have to put up a noise. Oh, actually I might just go straight to it. I'll just go straight to it. It'll probably be right. Let's do this. I had some problems with erratic readings before, but I think it's just a dodgy connection. Let's hook this back up here. Okay, getting a reading at least. And it's still heating, so it's drawing 386 milliamps when it's heating. It's good. Yeah, it's warming up. So let's try adjusting this trimmer, see what happens. Okay, still heating there, and still heating there. Okay, so it's heating right through the whole trimmer range. It's not shutting off yet, so okay, I'll stick that in the middle. And we'll wait and see what happens once it warms up a bit more. I've wrapped it back up in this little box. I've scraped away a bit inside the foam to allow for that new trimmer position, which is in there somewhere. I haven't actually aligned that hole yet. Still heating, and frequency's gradually coming down. So I'm going to have to leave this for a while, obviously, to stabilise, and then I've got to try and get a probe in there and actually see what the temperature actually ends up being. I'll have to dig a probe out. Okay, fished out my EV blog multimeter. Yeah, go Dave. Right, first time I actually used this temperature probe on here, so it's, you know, just christening it. I've got it poked into the packet here. It's just inside the insulation, touching the metal body, and it's 70 degrees right now, as you can see, and it started to control the current, which means it's getting close to the right temperature. The oh, this is set temperature. Before, this was really erratic. Even when it was working, it was jumping up and down over the place, so that trimmer was absolutely stuffed, obviously. That's what was causing those problems. So the frequency is getting there, kind of. I've still got some dodgy connections here, I think. Yeah, I've got something dodgy there somewhere. Getting some noise. Here we go, that's better. So, see how close that is now. Let's give it another digit. Yeah, so here we go. I think it's enough resolution. Just want to see how well it stabilises. Obviously, it should be on for quite a while before it actually gets set up properly. Let's move this one a bit some seed. So, oh, come on. Let me get both in there. There we go. Right. And yeah, the current's gradually dropping down, so it's getting very close to that set point, and it seems to be stabilising here at 71.4 degrees. So it's actually setting the temperature quite well. It's quite stable. That's quite good. I like that. Wasn't doing anything like that before. So it looks like I have actually resolved the problem. So what I'm going to do now is adjust this temperature to 80 degrees, hopefully. So the trimmer is in there. You can just see it. I don't know if you can, but I can see it. Turn up slightly. There we go. Let's just see what happens there. I'll come back. Alright, so I thought I'd just try a little experiment first. What I've done is I've turned the trimmer all the way down to see what the lowest temperature setting is, and it's stabilised at 62.6 degrees. So I just want to find out what the medium range is, and then I'll just guess that something in the middle was where it's supposed to be. So I'll turn it all the way up now and wait for that to come back up and see what actually the maximum is. Okay, it seems the temperature's stabilising. Current started dropping down to 130 milliamps now. It's just stabilising quite nicely, I think. So that's 82 degrees. So 62 to 82, so that means it's probably supposed to be 70 degrees setting. Or maybe 72 degrees, because that's bang in the middle. So what I think I'll do is I'll set it to 70 degrees, and then I'll align it all based on that. Okay, so I thought I'd just do a bit of research on setting these crystals up properly, well, as OCXOs, and apparently it's like a sweet spot on them where you get the optimal frequency response stability on a bell curve effectively. And I'm just watching the frequency right now and the temperature, and I'll just try in different settings and just tuning through the range to try and see where that sweet spot might be. I'm thinking right now it's actually quite close to it, but it takes a while because obviously it's all insulated. You've got to do nice slow adjustments to try and get this just stabilised. I mean, it's pretty stable there, but I'm still working on it. I was going to see what the optimal range is there for that one. Apparently each OCXO is usually individually set, which is why it's got the trimmer there, because each crystal is slightly different, so it's may not perform the same way, and so each one's tuned for the optimal temperature for that crystal. So that's what I need to be careful of, because before I was going to go middle of the range of the tuning. That's probably not the best approach. I'm going to try and do it in a more accurate way. So let's see how we go. So I should have mentioned what I saw happening is I did have this about 84 degrees, and the temperature was about the frequency was about the same as this, and as the temperature dropped, it dipped to a lower frequency, and now it's coming back up again. So that's telling me that that's the bottom of that bell curve, which I've got to look for. So I think the temperature I need is probably about 77 degrees. See, now it's shooting up a little bit, starting to jump up, and that's at 73. So before it was quite stable around 76, 77. It wasn't changing very much on here, and now it's changing by quite a bit. So I need to probably sit at the high 70 range based on those curves. Okay, so here's that web page PDF which I was referring to about the curve. So if you're at the wrong point of the thermal characteristics, you got a wider frequency difference for the same temperature range, whereas you come at a lower point in the curve, you're a much narrower range because it's at that flat spot there. So it says flat spot here, and the frequency is what I've got to try and aim for. So I've got to tune the frequency, tune the tip of the oven, so it basically bottoms out in frequency just before it starts to rise again. So I've got to get it right in that hill there. We get it right there. That's what I've got to tune it for. So a bit of spill there about what it's referring to. So that's what I've got to do, is tune it for that, and then I should be okay to put it back together. Okay, so I've been playing around with this temperature, and I've got it about 75, as you can see. That seems to be one of the better points to have it at. You see it jumping around a little bit here. I've only roughly set it, but it's jumping slightly. I've still only got 1 second sample time. If we go to 10 seconds. We're gradually changing temperatures and stuff, and it seems to be around 75 is where it's best, 76 maybe. So I've got the gate time 10 seconds now. So we'll see how consistent that is. I mean, it will be better once it's actually back inside its case. I think I'm actually getting a bit of noise coming from, because sometimes I'm getting some random numbers coming up. So I think I've got some noise coming in from probably from a Wi-Fi system or something interfering with the cables. So it's not the ideal setup, but we'll see. I mean, see, there you go. It's changed quite consistently there. But yeah, it's not too bad. I mean, look at me. What's that rated to? That's what's that? That's 1 kilohertz, 1 hertz, 0.1 hertz, 0.01 hertz. So yeah, so I think this one here is the 0.1 ppm, is it? It's 7654321.1. That one there, is it? Oh god, 1 million, 100,000. Oh, I really suck at this stuff. Don't change it now, it's awkward. Come on. 10,000, 1,000, 100, 10, 1.1. So that's 0.1 accuracy there. Part per million. So I'm actually, 0.01 parts per million really right now. If less than that, 0.001. But I mean, I don't know. That's only short term, but yeah, it seems to be doing okay. So interestingly, if I actually hold this can, I'll show you in a second. See, it's jumping around. If I hold the can, metal can there, drops and stabilises a lot. So I'm guessing the my power supply output's floating a bit too much. It doesn't like it, not good enough ground. So that stabilises it a lot. So I'm really happy with that. Because considering it's only a 1 second gate time, yeah, let's put it on 10 seconds and we'll see how long that, well, I was going to say 10 seconds, but we'll see how that goes. See what resolution I get out of that. Hopefully it stays fairly consistent. Oh, maybe not. Oh, of course. Like I said, I'm getting some electrical noise here, so that's probably related to the problem. 292, there you go, it's close to the first one. 294, there we go. So yeah, it does seem to like me holding that shield. Anyway, time to stop for today. I've got the crystal oscillator unit back in again. I've just done some slight alignment work on it. I've just set the course adjustment on it. It's been on for about an hour now, so it's probably warmed up enough. Well, just under an hour it's been on for. So it's just so that's the output from the oscillator just there. To give a minute, I've got it set up to 10-second gate time and maximum number of digits. So I'll take a little minute. There we go. It's not bad accuracy, is it? I haven't adjusted the fine control yet. So it's megahertz, it's kilohertz, 1 hertz. I'm trying to see this now. 0.001 hertz. Yeah, 0.001 hertz. Which not bad, and it's rock solid. So it looks like I've actually fixed that. Just need to do that final little bit of calibration work on it to get that nice. I've tidied up the ceramic there. I shouldn't really use the ceramic there. I should use something else. 10 PF. Yeah, it's a bit frequency, temperature sensitive, so it may or may not be a problem. But the oscillator that's in there, and the uncal is actually going away. Hold on, if I turn the iPhone up back on again, there you go. Uncal has now gone away. If I do, if I increase this output too much, it will go uncal as well. So there might be an issue with the output levels. Voltage was that? Come on. There we go. So anything above 1 volt is uncal. I don't know if that's normal or not. I might have to check the manuals, but yeah, it's working, and the output has got no noise. So the video on. Yeah, cool. It's working. So it certainly seems promising anyway. It's looks like it's doing what it should be doing now. I might have actually fixed it. I'll still get that noise when it first turns on. I think I'm going to have to go through the calibration procedure and actually just check this, because there's a certain way of calibrating it using a reference. And I set this based on the loop on the outside and stuff like that. But now I've got the crystal oscillator working properly, I can actually do that. I've only done the coarse tune. I've got the fine tune there yet. I'll set that in the centre before I put it all back together. So the fine tune is adjustable. I might just give that a slight tweak to get that bang on 10 megahertz. My frequency counter I know is bang on, because I calibrate that against a rubidium standard, which I've got here, and so I'm comfortable that's okay. So I'm going to set this to be the same as my frequency counter, and I should be pretty accurate with that. Okay, I've got my rubidium standard running just to check my calibration meter. It's still stabilising. It's only been on about 10 minutes, but it's still jumping up and down slightly as it's settling down. So there it is there. And you know, you can see how close the meter is, but it's just jumping up and down a little bit because it's still stabilising. It's not actually fully warmed up yet, but see, it's still pretty close. Okay, it's all stabilised now. You can see what the frequency is sitting at. So my count is slightly out, not much. So what we've got, that's 100 kHz, 10 kHz, 1 kHz, 100 Hz, 10 Hz, 1 Hz, 0.1 Hz. Bit of noise there. That's 0.1 Hz, 0.01 Hz. So it's 0.05 Hz out, which I suppose isn't too bad, is it? Obviously got some noise coming through now, but yeah, it was doing quite well now. Okay, let's come back to this. Let's give it more of a tweak. What I've done now is I've set the frequency to match what the rubidium standard was doing. So that should now be bang on frequency. Well, at least this should be bang on frequency. That's allowing for my counter being out by 50 millihertz, is that? Oh no, bloody, anyway, 105 hertz. So that's that all good. Let's just stick this probe on here. That's a bit slow. Probably having a 10-second refresh rate to wait a while. So that's the internal 10 megahertz, which I did have a closer than that before. Here we go, that's better. Must be a bit of noise. It's getting closer. Yeah, I might have tweaked that slightly more. Also, varies temperature. Now I haven't got the covers on, the fan's blowing across it and stuff like that, so probably won't be able to tune that properly until I actually get the covers back on it. Okay, so after sorting out the crystal oscillator issue, I thought I'd better go through and check all the actual frequencies now I can actually control it properly. And I've discovered that it's got some issues. There's a lot of frequencies that don't work, or they're 10 megahertz out or 20 megahertz out. The listing did say it was off frequency. But I didn't realise it was quite this bad. Some frequencies are okay. Sometimes a frequency will be okay depending on whether you've gone down or up to that frequency. So if you're, say, stepping through in 1 megahertz steps or something, using the cursor on the frequency display, if you go down it will fail. You go up to it, it's okay. So it's like there's some kind of IC latching fault or something. Possibly a VCO lock or something like that, which is wrong. I don't know. So I've gone notes through the entire frequency range. I did start at about 400 actually, but then I realised that something's wrong. Excuse me. It's 2 o'clock in the morning. I should really be going to bed. Right. I've been playing with this a couple of hours. So yeah, there's a lot wrong with it. So I'm going to have to look at the manual tomorrow and go through the theory of operation and see if I can detect anything which matches what I've discovered here, and hopefully I can get the thing to actually work. Because it'd be a bit of a shame after putting that effort into getting the crystal oscillator to work and to find I can't actually control the frequencies properly. So, oh well, we'll see how we go. Right, so I'm trying to diagnose these problems with the frequencies being out by 10 or 20 megahertz. I'll start with that bit. It's got a few problems. Measuring the VCO input over here, which you might not be able to see. Voltage here, frequency there. So the frequencies are strictly on the back of the VCO. This is set to 880 megahertz, so it's close. 870 is wrong, it's 20 megahertz out. 860 is 20 megahertz out. 850 is correct. I'll come do voltage measurements. This is on the controls voltage for the VCO. So if I do relative measurements, you can actually see the steps differently. So 850, which works. Now it's about 300 millivolts per 10 megahertz step. 860 is 300, see? If I do relative again from that one. 870, which doesn't work, has gone up 900, which is like 3 steps, which just makes it 20 megahertz out. So the control voltage is out by that much. If I go up one more, 880, which also doesn't work. 880 does work, sorry. 880 does work, so that's correct for 880. And that there would be wrong. So that's 890. So I think that's going to be doing 910. There you go, 910. So the control voltages are what is causing that problem. It's not the VCO fault, it's the control voltage fault. So at least I've narrowed it down to half the circuit. Need to keep narrowing it down a bit more. So I'll show you where I was actually measuring. A bit closer now. So this is the VCO circuit here, it's on the bottom of the board. The control voltage input is there. VCO output I'm measuring is over here. That junction of that resistor and that coax. That's the VCO output. So the control voltage is what's incorrect. So I need to trace backwards from that point. Okay, let's go through the alignment procedure. I've already done some of it. Let's try to use that as a diagnostic tool to figure out what else is going on. I did find that one of the VCO adjustments was out a little bit. I suppose it's set for 530 megahertz top end, and that was almost 540 it was actually set to, because of obviously aging and stuff. So I adjusted that. I don't know if that's actually helped anything, but what I'm just doing now is this stage here where that 10 megahertz internal crystal is adjusted in order to get the correct PRL lock in the 10 megahertz section. And this is the bit I'm going through right now, which is page 148 of 312. Yeah. And it doesn't actually seem to work. So what I've done is I've connected up as it's got here. Connected up my signal. I've got my Marconi signal generator inputting 10 megahertz to my oscilloscope and stuff like that. So because that's adjustable, and that's oven controlled anyway, so it's close enough. It's not perfect, but it's close enough. I'm going through this procedure here. That's okay, but it mentions about the signals being locked, right? So you've got you're viewing the two waveforms, and it should lock together, so they're in the same frequency domain, or at least matching frequencies. But that's not actually happening. I'm doing this adjustment. The adjustment itself is working, but if I adjust, it's not working. So it looks like this PRL section here isn't actually adjusting. I'll show you what I mean on the scope. Give me a second. Come here. Right, so I've got some bother dodgy leads. So the grey lead is my signal generator. This lead here is going around the back to the reference input. So the signal generator is providing a reference for this. That's set for external reference. The 10 megahertz output is fed back into channel 2 as per the service manual. So you can see they're not locked. If I adjust it here, it'll shift frequency, right? But it's not actually locking, it's drifting up and down based on the adjustment I'm doing. Right? So I'm adjusting up and down. They're not locking frequency. And this is part of a PRL system, so it should actually lock on frequency. Which means that this VCO in here, this is the adjustment in here. I've got that capacitor there, which I put in before, thinking I needed it. I'll just lift it one end just to disconnect it. So this is what controls the circuit here, this IC. I'm concerned that something is wrong in here, because based on the manual it should be locking frequency, then unlock again when you reach a certain adjustment, and that's not happening. So I'm going to have to look in this section really closely to figure out how the hell this bit works, because this doesn't appear to be working correctly. Okay, I've made a little bit of progress with this. It seems to be working at the higher frequencies now, whereas before it wasn't working at all, which might have been due to this adjustment I had to make over here for the PRL VCO. Right now I'm just looking at this. I've got it set at 470 meg and it's showing uncal. Now when I push the status button, it shows as 010, which is a main or reference PRL unlock condition, and that's the things I'm getting. So it actually shows that yes, the PRL is unlocked. So I need to trace that one down. Yes, that's always a bit interesting. So I need to figure out which part is causing that, and I'm going to keep looking, see what other errors I can get on status messages, help narrow it down. So I'm just going through this reference circuit check, and this appears to be faulty. It says that TP57 voltage change when adjusting R to 30, and it should be between 4 and 6 volts. I'm getting 12 volts constantly, 12.3 volts constant, not changing, which goes in line with what I saw before with the frequency not actually being locked, it's just drifting with the adjustment, which may also explain why the need appeared to be there for the adding the extra capacitor. Of course, it's over-tuned it to the right frequency, so it's probably that it's got a full voltage going there and it's not actually being controlled at the range it should be, which means it's going to be off frequency. What else is there? The other thing I found is I've got the crystal oscillator option there, the ovenized one, and I should be able to see that signal at U68 pin 3, and I can't. There's nothing there. And as far as this bit goes, U69 pin 6. That's there, but it's also the same voltage I'm getting at TP57. So I wonder if there's a short somewhere or something blown, which is dragging the two together. So because I know it's not working, and I just constant voltage here is pointless. So I need to look into this more. But yes, so I'm going to have to concentrate on this reference circuit before going anywhere else. Okay, so I've printed out the circuit diagrams for this thing to make it easy to look on the computer. And tracing through the RF, so you've got the OCXO comes in here, goes through that device, which buffers it, comes through, goes to this switching NAND gate here. Over here we've got the reference input, so you've got a reference coming from the outside with the switch on the back, turned on to external. Then it will come through here, goes to this device here, which is another switching thing, comes back out through to that NAND gate. So you should have 10 MHz on either of those pins, depending whether you've got input or internal or external reference going on. Then you should get 10 MHz coming out of this one, and I'm not getting that. So if I just probe on, probe in here. So if I probe, which was that? That was pin 5 of U54, so it's that pin there. There's the 10 MHz from the OCXO. If I go to pin 4, come on, get on there, don't slip off. Pin 4. Nothing there unless I turn the switch on. I'm feeding in an external reference. There you go, there's the external reference coming through. Right, so they're both there. If I go to pin 6, which is the output, there's nothing there. So I'll switch back on. So that's back onto internal reference, still nothing there. So it looks like this device might not be working because it's not passing through it. It's either that or the where are we here? So see that there's nothing on the output there, so either that has got an output or this is shorted. I'm going to have to try and figure out which is which case it is. I might just do like a ground check on the pin 3 and see if there's appears to be a problem there or not. and go from there. Alright, so what I've just done is I've just piggybacked another chip on top of this one, which I think is faulty. So that's U54, which is 74S00. I have a 74LS00P, which is close enough, basically the same device, and I've piggybacked that on top. If I probe pin 6 before, I had nothing at all. Now we have a signal. So that device is blown. That might help improve the situation somewhat. Okay, I've taken the pot out because it's such a pain to get this board out, because it is a major mission. What I've done is I've just cut the pins off, as I always do anyway on ICs, and desoldered it from the top, pin by pin. It's a bit messy right now, it's a bit of a clean up, but what I've got to do is actually solder this chip back in from the top. Now I'd normally put in a socket, but if I put a socket in I can't actually get to the pins to solder them, so I'm going to have to not put a socket in, I'm going to have to just go straight to a chip. I don't like to do that in case of another failure, but I've got no choice in this case, unless I want to pull the whole board out. Okay, the chip is installed. Again, we've got to clean it yet. See? So if I now measure pin 6, here we go. Signal. Right, so that's that issue resolved. So that's 2 issues fixed so far, and it's still not fixed yet. We'll keep going. Also, after replacing that IC, I've noticed that when I test the voltage here for the POL that's there, it's now correct. Well, close to it. It should be between 4 and 6. So I'll go back to the calibration section for this piece and try calibrating it now, because before I wasn't actually getting a voltage there. I was getting 12 volts constantly. So changing that IC seems to have helped that as well, because it's probably missing a signal. Okay, so we're getting there. Right, so I'm just back on this Fluke. This is for part 3 of the video. I'm still trying to diagnose what's going on with this. I've got some of it working, but as you would have seen in the other videos, but I've still got a bit to go yet. While just looking at here, this is all the how's it called? The main divider and stuff like that here. Sub mixer and such. So this goes out to the phase detector section here, which is then used to generate frequencies. There's a feedback in, well, feed in from the main VCO, and it goes back out, so to the VCO to control it effectively. Just like a feedback circuit. Now what I was actually just doing, I was trying to go through this because something somewhere is wrong. I know that this frequency here is wrong, and it comes through here, passes back out, and generates those frequencies which I know are also wrong, because this one's wrong. So I think it's actually further back than this, but I'm just going through here anyway. I thought, well, there's a little voltage regulator here. So I thought, let's check on that. I measured over here, well actually the output on the regulator I measured directly, and I was getting a low voltage, below 5 volts. And yeah, it's a 15 volt supply here, 120 ohm resistor, that regulator and that chip. Right, so there's very little actually going on here. And there's also another little resistor here. So I'm actually going to look at this and just show you through that. So I've already got one probe hooked up. So this is that's the regulator right there, and that's the IC it's running. There's little pull tab things in here. So there's that other resistor. So this is currently as it is. So you've got 15 volts coming in on this side here. There you go, 15 volts. And on this side here, I'm getting 6.6, which is a bit low, because the dropout voltage of the regulator is probably about 1.8 volts or something. So I measure on there, which is the output of the regulator, I'm getting 4.8, which is a little concerning. And then on the output of that other resistor there, still getting 4.8. So it seems to be that there's a bit of a drop in here. What I've got is, so it's a 120 ohm resistor that's in there apparently. So I'm just going to clip this on. So I'm holding the camera instead of having it on the tripod, which is not the best thing to do, I suppose. So, for the purpose of this video, it'll do. I'm going to clip this on. So that's currently set to 5.6K, so that's just helping very slightly, right? So that's that. Input, so that's 6.66. Output is now 4.9. Okay, so it's already come up a little bit just by putting it across it with the 5.6K. So it shows me that that the regulator is actually not regulating. It's not doing very well at all. So let's go to 2.2K. That'll probably be enough. So we're getting 6.7 volts. I mean, that voltage increase is not really coming up very much. And the output from the regulator is now closer to 5 volts. So it actually showed that yes, there was a problem with that. So let's just go 1K. Right, it's still 10 times more than the original resistor. So there you go, now you're getting 7 volts there. And 5 volts there. So yes, I might actually have to look at modifying this or finding out why those values don't work. That regulator doesn't feel warm. Not really, it's got a little bit of heat there, but not much. So I'm just going to try and have a bit of a feel around, see if I can find out why it's not working right. You know, you would have thought that the default factory values would be fine. I'm not feeling anything here really. I mean, that regulator's got a little bit of warmth in it, but hardly anything. I expect a little bit there, but it's only running one chip, so you would think it'd be okay. So I might just strap a resistor across that, because obviously I don't want to put too much voltage into the regulator, because otherwise it starts working harder and it puts out more heat. So I need to have just enough to get the regulation voltage. So that's currently the 1K. I should actually have a look at the spec and see what the official dropout voltage is for this thing. So I'll just put up to 820K, 820 ohms, sorry, 7.2 volts going in now. And that's a nice 5 volts coming out. So I'm wondering if maybe that IC was not being driven properly with voltage, under voltage, which would have affected a few things, I'm sure. So I'm going to try that out and see what happens. Okay, so I'm just trying to diagnose the PRO unlock issue I have, where that's floating around on the output, as you can see, and I've got it set to 39.33. If I go down to 38 or so, 37, there you go, 37, that's what I get. If I go back up to 39 again, or even 38 does it, I get that instability. Now what I've just found, if I come over here with a bit of freeze spray, if I just put a little bit of freeze spray on this chip right here, it's better. And if I go to 39 megahertz, is that 40? Okay. So I had two issues. There's one that's coming unlocked, and the other is that it jumps like 20 megahertz sometimes. So, but this seems to be what resolves that problem with the losing lock. So if I that says it's locked right now too. If I come with the heat gun, just heat up a little bit like that. Unlocked again. And uncow. And if I spray that chip again, show you that. Okay, so it's like that chip, or possibly a poor connection just there somewhere is the issue. So I'm going to have to pull that chip out and have a look and see what I can see. So looking at this part, that is U18, which is this device here, U18A, U18B, and according to what I could find out, where are we? Find it. It is a dual type D master slave flip flop. So this is the device, and that's the pinout. So I have found some online. I've just purchased them, so at least I can get some new chips coming. Although a batch of 5, so I'm fairly confident that chip is one of the faults. So I bought a few of them to make sure that I've got spares in case I ever need any more. You never know. And that's certainly a good start. But I'm not sure that's not the only problems around here. I still have that weird issue with it skipping 20 megahertz. That's a bit tricky in itself, so I'm still trying to track that down, but this is not an easy thing to troubleshoot. Okay, one of the other issues I identified with this is that if I'm sitting at, say, let's get the camera on it, 10 kilohertz, right? That's 10 kilohertz. So you've got 10, 20, 30, right? 40 works, but 30 didn't work, 20 works, I think, because it's just stuck on that, and 10 works. 10 doesn't work, right? So 10 and 30 don't work. It will give the same reading. Now, if I look at the Fluke camera, so that's on 10, that's on 20, that's on 20, that's on 30, that's on 40, which is correct. Now, if I do my little trick here with the freeze spray on that chip, which I've already found is causing the lock issue, I'll really cool that down a lot. Seems to be quite a bit. So that's still on 40. Now it's on 30. That's on 20. That's on 10. So that same chip is causing 2 of the faults I'm experiencing. So I say I've ordered some more of those, but it's going to take probably a couple of weeks to get them to turn up, if I'm lucky. Which is a bit of a shame because I want to get this thing, you know, completed. But in the meantime, I'll keep on looking for other faults. I know there is another fault present. So that is actually 2 of the faults I'd identified. Is that one chip that solves both of them, which is brilliant. And there's only really one fault left then that I'm aware of, at least at this stage, and that's the 20 megahertz offset. So if I let's stick this up on a frequency that does it. There we go. Right, so that's on 81 megahertz. Ignore the 01. No, I'll round it off. Make it nice. Okay. So that's 81 megahertz, right? I'm getting 101. So it's 20 megahertz out. That's the other fault I have to find. Sometimes it's not always that by that much. Sometimes it's bang on. It's fine. If I go to 71. It also changes if you're going up or down. So if I'm going up, so if I start with a low frequency, which I know works, like 21, that's fine. I'll do 31, it's fine. 41, 51, 61, 71, broken, right? But note that 61 and 51 worked just now when I was going upwards. If I now go downwards, so 61 is 81. It worked last time, now it doesn't. And 51 is correct, right? But if I go up more, then it's so if I'm going upwards, so 61 there, 61 there, go to 71, so faults. That's now 91, even though it's set at 71. If I go back down to 61, 81. So, but if I go down to 51 again, then it, 51 now says 71, right? And 41's come right. Okay, so there's a intermittent fault there. It depends which way this frequency is being stepped, up or down. If he's stepping up, it doesn't tend to show up as much. If he's stepping down, it shows up a lot more, or it stays faulted for longer, should I say. It's probably a more accurate description. But that's the other fault I've got to find. I don't know where that is yet. I've done some diagnostics on the buses by measuring these ICs here. These are latching ICs, so it gets the data and latches the data on. You can see what data is coming out of the ICs, and it's got a test mode on here where it alternates the bits, ones and zeros, and you can actually see the data on those pins as correct. So at least at this point the bus is correct, for the bus I checked anyway. but there's obviously some kind of fault somewhere else where it's stepping by 20 megahertz and not the right amount. So I'm guessing there's some kind of binary problem somewhere where it's probably on the edge of triggering and it's not quite flipping over properly. That's what comes to mind. It's like there's the the second bit is it's not switching properly. It's always either 10 or 20 out. If it does it, usually 20. Sometimes it's only 10 out. So, and other times it's absolutely bang on. It's fine, and it seems to be around certain frequencies. So I need to try and figure out what the binary codes are going between the devices which are controlling the actual frequencies. But unfortunately, the manual doesn't say enough about that. It says, this is the controller board and that sort of stuff, but the actual information on how the controller changes the frequencies, what binary codes it uses and so on, there's nothing there. So these are EPROMs for calibration, store calibration data, main CPU, which is fairly warm. But yeah, it's being a pain, but I'm pleased because I've made no progress in the past 2 days. I've sort of been sitting and scratching my head trying to figure things out. I'm trying to do it logically. I knew it's something around here, I didn't quite know where for the POL lock, because I couldn't actually fault it. I knew that the voltage coming out here at this point, which goes to the output side, or the main VCR on the other side, that was wrong, and that's fed from here, and all this seemed to be okay. It's had some work done here. I can actually see that these two transistors here, unfortunately the lighting's not very good now, it's got dark, so let's get my torch out. Let's do better. Right, ooh, probably a bit too good now. Right, so those two transistors there, right in the middle of the screen, what numbers are they? Q16 and Q17 I think it was. Yeah. They've been worked on. I can see they've been resoldered. They're really hot and they've got a flux around them and stuff like that. At least it looks like they've been resoldered. It had flux there and it's been getting hot, but that part of the circuit is getting hot anyway. And I gave that a clean up and got the flux off and stuff in case that was causing any problems, but it didn't seem to help at all. And there was interesting marks on the casing actually, just in this area, as though something's blown out, like maybe it had the FM board in there or something, or I'm actually guessing the casing that I took off wasn't from this unit, because it's got witness marks, the components blowing up, but there's no witness marks on this board to say they've done it. So I'll begin now. To give you an example, just above here the low rate FM option, which this doesn't have installed, and based on the components which are still in place, because some components that get left out for that or removed for that, they're still in there. So I don't think it's ever had that option either. And it's not marked on the back as having it. Right here there's a burn mark on the bottom of the cover. There's also another one about here somewhere, but there's no signs of any problems on this part of the circuit, so I think that cover's actually from a different unit. So I'm guessing someone's been doing some part swapping and stuff on these, will make it a little bit harder, which I hate, but yeah, it's getting close. I mean, a lot of it's working. If I stick it on like the monitoring channel of my radio there, 26.33, it works. It outputs a signal, the levels look about right, and it's got audio, right? So it's really close, but it's just this frequency control stuff which is driving me nuts. So now I've found that chip there, which is U18. It's the MC1031P. So 101, yeah, 10131P. Obsolete part. Lucky I found some. So anyway, I've ordered from found it on eBay, AliExpress, and FutureLink. So I've ordered them from all three places because they're only a few dollars each. And whichever one gets in first will get in the radio, will get in the unit. So that's all that done. So at least that should cure two of the faults I'm experiencing. That will just leave me with that 20 megahertz shift thing, which I've got to figure out somehow. Right, so I was going to, I've got my logic analyzer hooked up to this IC just here, which is the end divider. It gets data inputs on here, which I'm trying to interrogate, and that goes out to the phase detector to control the frequencies. So I wanted to verify this is getting the correct data. Now in theory that'd be great, you know, you just check the letter, see what data's going to those pins and say, right, interrogate that, find out what value it's getting in binary to those pins to work out what the divider's doing. Yeah, one problem with that. That's the data. Bit more complicated than I was expecting. I was expecting to see, you know, a couple of pulses or something, you know, to set the bits, but I'm not getting that. And this is all the data. Yeah, it's more complex than I really want to try and deal with. Oh, I just re-triggered. Right. Yeah. So I'm not too sure what the hell I'm going to do about it now. It doesn't help the scope has got some little bugs in the data for the digital system. I don't actually know if there's a firmware update yet. I should go back and have a look. I did raise the issue with Siglant about these bugs in here, so if you like try and do a re-trigger, if you stop that and zoom in and get the data, right? But there's situations that so it's running. Let's re-trigger it again. Right, zoomed out right now, but anyway, so that's on normal, so it's done a single trigger, and you try and zoom in, the actual data readout on the bottom doesn't come up, so it doesn't, you know, this all zooms out, but the data on the bottom doesn't, so you can't actually interrogate what each bit is doing, which is a bit of a pain. If you do a stop, then it's okay, but it's you know, it's not as good. Like even if you scroll this left and right, you see the data's moving, but the actual values are not. So that's not that helpful, I'm afraid. Anyway, but yeah, you can work around it by doing the stop, and that seems to work then. But yeah, it's a bit of a pain. Anyway, that's just my little bug. It does work, but anyway, as I was saying, the actual data is far more complex than I wanted it to be. So I was hoping just to find, you know, a binary section across here, you know, saying, hey, look, bang bang, that's the binary, but nah. This is way more than I wanted. So I might have to go and do some research on the chip if I can, and try and work out what the hell this thing's actually doing to try and read this data, because as this is, I can't interrogate that. I've got no bloody idea, you know. I'll display hex binary or decimal values for the actual data. I was hoping to find a binary. What I was hoping to see is a single binary data set which told me what the in divider was actually doing, but it looks like it's sending several bits of data, you know, dozens and dozens of them. So I don't know. I mean, I could even be interrogating anything correctly. I could have the wrong settings on here, but I've got no idea what I'm doing with this. So anyway, so I thought I'd just show you that. This is just, you know, yeah, I'm getting a bit desperate with this thing because I'm actually running out of ideas. You know, I know that chip there has failed, so I'm waiting for parts for that. I can't do much about that until those turn up. So I'm trying to work out on that 20 megahertz error, which it has, which I was thinking, well, maybe it's a divider which isn't, you know, getting the correct data, or maybe it's getting the correct data but it's not doing the right division, so it's not actually outputting the correct frequency for the phase detector. I don't know. I'm still trying to figure out where that 20 megahertz error is coming from. I've done various testing around various bits and pieces and various frequencies and such, and they all seem to be about right. So I'm not seeing any other errors, well, any other faults. So yeah, I mean, there's obviously something wrong somewhere. I just don't know what it is or where it is yet. So it's a bit frustrating, but you know, I'll get there. I mean, it might just take me a while. But yeah, this data here is that's just incredible. That is way more complex than I was expecting to see. Yeah, that is just too much. You know, I was hoping for a much simpler bloody system than that, but anyway, this is actually the reason I bought this scope, for this logic analyzer function, you know, because I thought that's a great handy thing to have, and it has been very useful. I've used it to diagnose various things, and actually allowed me to fix a Fluke 8842A multimeter. Actually I went diagnosed that it was a analog to digital converter which failed. I actually got a video on that online, one of the earlier videos of my electronics testing stuff, and that shows me diagnosing. It shows the data and it shows the readout on display. So anyway, that's besides the point. Right now I'm trying to deal with this one, and yeah, it's not going well. Awesome. Oh, I've got the generator on. I've actually installed some more lighting, as you can see, reflecting off everything, which might not be a good thing. So I've got it on 51 right now. I've got my new spectrum analyzer set up. I'll just stand over here so I don't reflect on it. So it all seems to be working okay. Well, spectrum analyzer anyway, the generator's not. That's sitting at 71. I've got it set to track the signals and peak search, stuff like that, so it automatically follows it when I step up and down. So I should step by 2 divisions at a time, if it's working correctly. Gone. It just vanished. So that's because it's playing up. Let's give it bigger spans, hopefully it'll capture it. That makes it slower. Hold on a second, this bandwidth resolution. I'm trying to get used to using this thing. I'm getting better at it. More used to it anyway. Right, so there we go. That's stepping. Should be about 1.5 divisions now. There we go. See a big step in. That's when it went wacky. What I was trying to verify is that the actual signal wasn't all noisy, and it's actually a proper signal. I've got the resolution set quite big to make it a faster scan rate, but main thing I was worried about was the actual noise coming out of it in case it had a fault which I wasn't picking up, like broadband noises on it. I've got the spikes here and here, which are interesting. Let's turn the RF off. Yeah, interesting. That's curious. I was probably picked up a different spike. That's more always a bit of carrier. That one there be carrier. That's probably a internal reference on this thing. It's picking up some internal stuff. Hopefully, if I step it down, it should get better. It's 1 megahertz there, so it's probably, yeah, okay. Yeah, it must be like a 0 megahertz reference or something. Right. So hope it'll follow it up or go back up. Right. Yeah, so that's interesting. Anyway, the output seems to be okay. I mean, there doesn't seem to be any noise. I mean, that's with it faulted. That's doing 101. It's going to be doing 81 here. Yep. So the actual output looks alright. I'll increase that resolution just to prove it. Yeah, let's go 1 kilohertz. Make the span a lot narrower. Let's go 10 megahertz span. So it still looks okay. 5 megahertz span. Yeah. 2 megahertz. 1. I mean, it's not looking particularly noisy or anything, it all looks fine. 0.5 megahertz. Yeah, so although it's the wrong frequency, it's not noisy, it's just okay. So let's turn the modulation on and off on AM, FM modulation, just there like that. So let's just give it a bit more. 0.2 megahertz span. So I mean, it all looks fine. I mean, you know, this looks the same as it does when it's given the right frequency as to when it's given the wrong frequency. So I don't think it's a mixer fault giving junk out. I think it's purely being controlled and set to those frequencies. So at least I've eliminated that as a possible thing, which is, you know, it could have been giving us a spurious reading on my Fluke counter, which wasn't the true output, but is what the strongest signal was, because it was just happened to be working that way. This shows me that yes, it's actually giving that fault. So I know definitely it is on the wrong frequency, and the noise stuff isn't actually an issue. You know, that's okay. So yeah, it also shows me that the output from this is looking about right too, because that's seeing 0 dB, which is what I've got it set to, which is also another good sign. Actually, I'll just try messing with the output. Amplitude, just to see if there's any known issues with this. That's -10, -20, -30, -40, -50, 60, 70, -80, right down there in the noise floor. I can probably bring this up, but I don't know how. Yeah, amplitude, attenuator. That's already, yeah, that's already right down. So, yeah, okay. I don't know. I'm still figuring out how to use this thing. So I only got it a couple of hours ago. So, you know. Right, so that's down there. So that's -80 there. -90, this here into noise floor. Yeah, it's just like gone. So let's go up. Let's put the attenuator on. Let's go 50, 60 dB attenuation. So that's doing 0 dB there. I thought the attenuator should bring that down. Unless I'm doing something wrong. I would have thought that. Okay. No. I don't know how to use this. Reference level? I've got no idea. Right, I don't know how to set this. Okay, let's just try tunging it in. Let's go 20 dB. 50 dB. I don't know how to use it. Anyway, so it's showing 0 dB there anyway, and it shows as I'm scaling it down. But that's okay. I wonder if it will make it scale down if I increase it. That's 10 dB. Nah, 20 dB. Anyway, so yeah, so at least the attenuator part of this generator is working correctly, and this appears to be working too. So they both correlate with each other. So the chance of them both being bad by the same amount in the same directions, like minimal. It's yeah, I don't know. I just don't know how to use this properly yet. But at least it seems to be working. This sticky, I figured this out now. That is a sticker. That's actually an upgrade sticker, not a downgrade sticker. The default version of this goes to 1.5 gigahertz. This is an option. I think it's H18 or something like that. And it's actually got a bandwidth upgrade in it, which is why it's a sticker. So that explains that. Which also explains probably why the noise is a bit higher at the top end of those 1.5 gigahertz upwards range, because there's obviously an adding thing they'll do. Anyway, won't worry about that. So right now I've figured out what I need to figure out. This is not putting out noise, so it's not a mixer error which is causing that frequency. So it's shut this down for now, and I'll go and find something else to do for a little while. So I'm still working on this beast. I've made no progress at all today. I will go back and look at the digital side later on. Maybe tomorrow I'll go and do something. It's actually quite late now today. I don't have much time to put on it, but I've gone through and I've actually tried swapping parts, so the ICs which are in sockets, sometimes there's several of the same one, so I actually tried swapping them around to see if it changed the fault. No luck with that. So there's also various parts which I couldn't swap around because there was only one or so in there, or one of that type in there. I've gone through my various ICs and parts and stuff, and I think we've got an M358 up here, which is an op amp. We've got a 339, which is an op amp. We've got a LF347, which is an op amp. TL074, which is an op amp. Alright, so those kinds of devices I've gone around and substituted another device which has got equivalent specs to see if it changed anything, without any luck again. So I've returned it pretty much to original, apart from the ones I swapped around because they're the same parts anyway, so they shouldn't actually matter. But things like, you know, the LM358, I swapped that out for a 4558, which is actually a better spec op amp, and that didn't change anything. And these various quad amps as well, swapped those out. I think there's only one or two devices I haven't actually swapped out. We've got a 74LS390 there, which I don't have any of. That part now, which I'm waiting for parts. MC10102P, which I don't have. MC10105P, which I don't have. I sort those around. Yeah, that's an op amp there, just changed. Without luck. Those were the same devices anyway. I think they're all working fine. I've already done testing on those. Those analog devices, I left those alone because I don't want to risk breaking them, because they're probably impossible to get. I swapped that out, swap those around, here we go, 74LS244N. Let's see how one I haven't done. There are some in here, but they're soldered in. So I think there's another one up here somewhere, but it's the only one I've seen on a socket. Mind you, I haven't looked on the bottom of the board, but anyway, so I haven't changed that one out. Yeah, so, and I've just lifted these big devices here just slightly out the socket, wiggled them a little bit and pushed them back in, just in case of a bad connection. No luck. So by just randomly trying different things, I'm not having much luck now. I think I'm running out of I don't know, yeah, luck. So I'm wondering now if I should be looking at the next board up, because it does appear to be a control problem. I can't tell exactly where that control problem is coming from yet. Yeah, so it's got a EEPROM there for VCO calibration. Maybe there's something wrong with that EEPROM. Maybe it's lost some data. I'll probably just probe that and just see what data that's actually outputting for calibration specs, or calibration compensation rather, and see if it jumps or does something weird when I've got that fault present. That's probably where I'm looking at next, is just checking that in case that is completely screwing the rest of it up or something. These devices, I'll probably just lift them and push them back in again. That's attenuator, and that all seems to be working fine based on the output with my new spectrum analyzer. So that appears okay. Output, I'm not sure that was actually output was for. That might be modulation. I'm not sure. Anyway, the only one I'm really worried about is that VCO. I think got these devices here. Obviously ROMs. Oh, there'll be ROMs as well, I think. Yeah, there's EEPROMs on full of windows under there. But most of these other parts are soldered in, which is a bit of a shame, because you know, it'd be nice to pop one out and pop another one in just to rule them out, you know. And I'm not going to unsolder them unless I've got a reason to suspect them. Yeah, this is something that worries me, is this processor. If that's gone, it's screwed, or if that's gone, I'm screwed. If that's gone, I'm screwed. A lot of these other parts are fairly common, or there are substitutes I can use. So it's just the proprietary stuff I'm really worried about being a problem. But anyway, it's just driving me nuts really, trying to find out what this 20 megahertz step is, you know, where it shifts by 20 megahertz. Randomly. It doesn't always do it. It doesn't always. Yeah, I don't know. You know, I said it in other videos. Sometimes it'll it does it less going upwards in frequency, it does going downwards in frequency, which seems to me like it's a threshold problem on a switching of a device. But it's, you know, close to that, like 1.5 volt, 2 volt threshold, or 2.5 volt threshold, whatever it might be, or 3.3 volt, whatever the device might have for specs for the threshold voltage between a 1 and 0. It seems almost like it's something like that, where there's a voltage loss and it's not quite getting over that threshold to switch properly. It's almost like it's a state from the previous frequency, and it's not being rewritten with a different state because it's not actually switching. It just seems something like that. That's where my instinct is right now. Yeah, but I'm just a bit lost right now. I'm starting to feel a bit out of my depth with this one. I like to make progress on things at least a little bit every day, and today I made no progress. I made some progress, was it yesterday, day before? Yeah, so it's getting a bit frustrating, especially when I bought that thermal camera to help track it, you know, to look for any hot spots on the board. As you will have seen I think it might be no section in this video actually, but I recorded some previously. That camera is actually faulty, believe it or not. It worked for a while, then it stopped. The screen just goes white, so not impressed by that, especially when you pay $300 US for it. Anyway, so needless to say, I've lodged a dispute with AliExpress saying, hey, this thing's faulty. So we'll see what happens with that. It's early days yet. It might end up being replaced anyway, so we'll see. It seems like a thermal problem, so I might be able to open it up and just fix it myself, but we'll see what happens. Yeah, so really I'm just trying to figure out where the problem is. I might just I'm actually tempted just to go around with my probe and just test random parts, you know, like diodes and things like that. Actually, it's not a diode, it's a resistor, but yeah, there probably are parts around I can just randomly check and just see if I can stumble across something that's not quite right, or do voltage checks on every single IC, that kind of thing. I've already done some checks on various ICs, especially like around here. I've done around here and a couple around here as well. So, but I haven't checked anything up here. So I'm actually starting to wonder if maybe I'm looking in the wrong place. You know, it's because it could be a control fault, and it could be one of these logic devices not working correctly, or a bad solder joint or something like that. You know, you've got these little plugs all over the place and these little interboard connections. I've already checked these interboard connects. They seem to be fine. So yeah, I'm getting a bit lost with this right now, but there's still things to check. So I'm not run out of ideas yet, but it's just getting to be a bit frustrating. So we'll see how we go. You know, I'll probably there's actually a chance what I'll do is I'll just stop working on it for a while, do something else, and come back to it later on. And just when I actually feel motivated again, my motivation dropped a bit for this right now because it's being quite challenging. You know, because I don't understand it well enough yet to actually to know where the fault could be. I've had a few ideas, but they haven't worked out to be that. So I think I really just need to get my head around it, take some space away from it, and absorb the manual and try and get as much information out of the manual as I can about how a thing operates, and try and figure out where it could be. And I thought it could be a mixer circuit or something like that, or a flip-flop which is part of the VCO and things like that. But apart from this one here, which I found, it hasn't been that. So randomly changing devices around here doesn't seem to have changed anything. There was that factor here where these had been worked on, these two transistors, so I'm still leaning towards maybe something here. Maybe, I mean, they look like the right parts. I think the part numbers were correct. I think I did look at that, but and they did seem to check okay, but I'm actually tempted to take them out of the board and test them out of the board, out of circuit, and see if they seem like leaky or something like. Because you never know, it could be something like that skewing something or causing a VCO to not quite run at the right frequency or something like that. But I mean, the VCO control voltage is changing when the error's there. The voltage is wrong, so the VCO has been told to generate the wrong frequency. So and it comes from here, which is fed from this lot. So it's hard to say right now where that fault is. Is it coming from over here? You know, something here wrong, or is it from up here? I'm running out of things to rule out. mean, I've checked the tantalum caps. They all seem fine. I haven't found any which have been shorted or anything like that, or open even. They've all had some kind of reading on them, and it's always been a pretty much right reading. So, you know, in the electrolytics I can't really check because I take the board out to do that. But there's no signs of leakage, so look good. I mean, these are Nichicon caps and stuff like that. So, Nichicon? Dippon Chemicon, sorry, Dippon Chemicon caps. So, yeah, I mean, the chances are they're fine anyway. The ones I have been able to check have been alright. Yeah, and I can't see any like noise on power supplies or anything like that. Everything's always looked fine. So my ideas are certainly running out. But anyway, I'm hoping I'll get there in the end. But anyway, that's enough of me blabbering on about frustrating bits of tester gear. So I like a challenge, but this is being a real challenge. So I'm back on this again, still, whatever. I think I'm still on part 4. I haven't done another video of this yet. Anyway, I'm just measuring the DAC output, which is supposed to control, well, it's go towards controlling the main VCO. Now, I'm just trying to pinpoint where the VCO frequency is being controlled from, and to try and determine backwards from that what is going wrong. Right, so I'm trying to do this in a logical way. I've done various random stuff in the hope that I might just stumble across something, but nothing's actually worked. I even resulted in swapping those two DACs there around. Where am I? I've got the camera upside down, so it's a bit different. Right, those two DACs here, so I did swap those around in the end. I didn't really want to disturb them, but I thought, well, if there's a DAC problem, I might be able to identify if it's a DAC or if it's something else external to that. So I'll swap those around, and the fault is still present. So I thought I'd go to the next stage, and test point 37, which is just here. In that section, and on the diagram it's just there. So that's one of the DACs coming in, right? K and V. That's that DAC coming in. It goes through this circuit here, which is a voltage current converter thing apparently. It comes around here, up back here, into the input of the op amp, which is what drives the voltage out to the VCO. Right. So I'm just trying to trace around what's causing this VCO voltage to jump by twice as much as it should do, well 3 times as much as it should do. So I thought, well, I'll start at the DAC because that's what should be generating the frequency in the first place, or the voltage to control it, because that comes from a digital converter, because I couldn't figure out that digital circuitry. Where's that diagram? Is that it? Hold on a second, try and find the right bit of paper. Not that one, hold on a second. I'm trying to find the right piece of paper which shows what I was talking about. No, I can't find it. Hold on a second. Oh, there it is. It is right in front of me, idiot. Right, okay. I think that's the right one. No, that's what I was looking at. Anyway, hold on a minute. I'm still confused myself. I'll come back to this. Hold on. Right, I think I actually ran out of memory on my phone and stopped recording halfway through, so I'm going to record that bit again. This is the bit I was testing before with the digital signals, using my logic analyzer, trying to determine what was going on in the input to this end divider, determine what it's putting out for the phase detector signal. That comes from here, and it's also got another 1 MHz input from somewhere else, which I forget where it is now. Might be up there, maybe. I can't remember. Then, as you saw, I couldn't identify what was going on there. It was too complicated. I probably could have narrowed it down by, you know, doing a chip select or something. It's probably because it is a bus. It's probably controlling all sorts of stuff at the same time. But that was too complicated. So what I've done is I thought, right, I need to figure out which point in the circuit is faulty. Obviously, I know that the VCO output to the main 800 MHz VCO, which is this here P102, I know that is stepping by the error amount. So if it's out by 20 MHz, this control voltage here is what is stepping by 20 MHz. Right? As I've done in the previous video, I showed that. So I know the fault is somewhere either passing through this or within this part of the circuit. So what I thought, with that end divider, I was trying to Pro before, that actually feeds some other stuff on. Where am I? Yeah, it feeds its phase detector here. Sorry, it feeds its phase detector. So that's one part. But there's also, if I can find the right drawings, here. This is some other digital chips. I've already checked the digital on these. These are actually latches, so that actually, the reason to check, it just latches the signal. So I've already checked all these using a test mode on the actual instrument, and all these checked out fine, which made me quite confident the digital control signals are okay on the bus, because otherwise I probably wouldn't have measured them right. Just here are the two DACs. Now what I actually did take those two DACs out and swap them around, just in case it was a DAC fault, but I didn't change anything unfortunately, so it didn't know anything there. So these two DACs go out, and you've got two voltages that come out of those DACs, KNV and KVV. Right. Now these come back over here to this circuit, which feed this oscillator circuit here. Okay. Now we've got the KNV DAC coming in here, test point 37, which is what I'm currently hooked up to. I'll show you the testing in a second. And I've also got another DAC up here which I need to hook into yet and test that one and see what's going on there. So if I just need to determine whether it's a DAC fault or whether it's a phase detector fault, because one of these inputs is controlling this output, so I need to figure out which one. And that's the hard bit, you know, trying to determine what is causing that 800 MHz VCO control voltage to be wrong. So anyway, I've got it hooked up onto that 37 test point there, which is just here. Excuse me the mess, I'm trying to do stuff at the same time. So I'm currently set at 41 MHz on display, and I'm getting 41 MHz out. And I've got the offset set at 0 volts right there, so I've already measured the voltage and set a relative measurement. So I was measuring minus 1.577, as you can see, right, on 41 MHz. So if I go to 51 MHz, it should be 51 MHz, that's actually just errored. So it's showing 0.03. But I'm currently getting 0.71. That's an error. I shouldn't have been. I'll just go down there. So I'll get that 51. No, it's decided to fault now. I did it before the first time around. I did this. Come on, do me a favour, give me 51. I'm getting 61. That's on 41, so it's giving a fault. Right, okay, that'll do. I showed you 41 just now. That's on 61. It is set to 41. The voltage is the same. Okay, this is what I was trying to show with 51 MHz. I did it the first time around, but the video didn't record properly. So what it basically shows is that whether it's generating 41 MHz or 61 MHz on a counter, this voltage is the same. So it isn't the DAC output which is causing that, at least not that DAC. Alright, so this KNV DAC here on test point 37, that voltage is not changing when the fault occurs. That's still in line with what it should be doing. So, and if it's a different frequency it generates when it faults, the voltage is the same as it should, as when it doesn't fault. So that's okay. I've eliminated that DAC. Yay! Alright, anything I can do to eliminate things is as good as finding the actual fault, because eventually you eliminate everything. Okay, so that's that DAC there, measured. Now I'm going to pause this video and probe the other one and just figure out what I'm going to do there to just demonstrate it and go from there. Well, I'm hooked up to the next test point, which I've got here. I had two to choose from, I tried them both. Hooked up to 33, which is just hitting the op amp. So that goes through the system here, through these amplifiers, well, switches, MOSFET switches, and whatever they are, some kind of FET switch. 2 op amps. This one's a high pass filter system, and it goes through this transistor here. Well, another MOSFET. Okay, so this appears. This is all part of the FM circuitry, right? So this really shouldn't be doing anything. because I've not even got any modulation turned on. It's nothing. So anyway, I'm testing test point 33. So this one just here. I'm on 41 megahertz and I'm getting 41, and I've got that voltage. So it's actually about 0.84, I think, 0.0084, because I've got the offset set on there still. But so I'm stepping through, and it's faulting now, and that voltage there is not changing at all. So the other DAC isn't doing it either. I think the other DAC's only there for modulation offset, because it has to double it and halve it and stuff like that. So up to this point here, that seems okay as well. So yeah, that's helpful. It seems to have eliminated both the DACs, which, you know, was a concern, because it might be a bit hard to get, but I don't know. Or it might be easy to get. I don't know. I haven't actually looked. But so that means that, you know, this input here is okay. The input there is okay, which has narrowed it down a bit. It could well be phase detector problems. I've done a lot of discrete testing. I've tested all the diodes. Every diode I've tested. I've tested all the transistors. Nothing has shown up really as being a problem, apart from Q16, Q17. I'm getting some odd measurements. I mean, I haven't taken anything out the board, but I'm having trouble measuring those two. And those are the two here, which, let's get these out of the way now. And where am I? Over here. Those are the two there, which I said have been worked on, or at least they're very hot. These two resistors are quite hot, but then they're power ones anyway, so they're quite chunky ones. So maybe they designed that expecting that to get hot in the first place. So, I don't know, but yeah, those have been worked on at some stage, and I'm getting weird readings off them. So I'm not sure. I mean, these are supposed to be amplifiers, and also this transistor over here, Q20, that front one there, that is also giving me some strange readings. That's also another amplifier. That's an MPS A18, and these are MPS 918s. So it could be one of those are causing a problem. The only things I haven't found which are working correctly, well, don't appear to be measuring correctly. So yeah, at least I've narrowed it down a bit to know it's not the DACs. I'm still going to do more probing around here, because I mean this circuit here is generating the voltage for the VCO. So either it's been told to do it incorrectly, or there's some fault in here. Because it's a nice round 20 megahertz, that made me think it's a digital control issue rather than a discrete fault. I mean, which is, you know, why I started checking the DACs, because they are digitally controlled. But those seem fine. So it's narrowed it down a bit. I'm still leaning towards digital control problem, but I've already tried replacing or swapping out various parts in this whole system. You know, changing between parts here for any faults moved or changed or exhibited any different symptoms, and nothing happened. So I'm fairly confident the actual discrete components, or the ICs, are mostly okay. There's a couple here I couldn't check, but yeah, I'm still at a little bit of a loss. I want to measure over here now. Was it test point 40? I just want to check that one and see what's coming out of that op amp. So I'll just pause this for a second. Okay, I'm hooked up to test point 40, which is, say, the output of that op amp there. This is the voltage that's there on 21 megahertz, so it's 11.4 volts. I'll set a reference point there. So if I go to 31 megahertz, I step up by 0.3. 41, about another 0.3. Okay, cool. So I'll make that reference level there. So 51 should be another 0.3. See, voltage there is different. Okay, so that's gone up by 20 megahertz too much, and that is 0.6 too much, which is 20 megahertz worth. So at this point here, that is too high. That eliminates all this lot. Okay, so I know at this point here that's wrong. So what's causing that? There's a TP56 here. I might just check on that one. So I've already measured that line because that's the one from over here. That line measures right. Hang on a second. That's interesting. Oh, mind you, there's a resistor in line there, sorry. Just there. Okay. So I need to measure the input of that op amp directly, really, to see whether the input is wrong, whether the op amp's doing something strange. So that's pin 2. So I'm going to pause this again and come back and have a look. So I decided to try and eliminate some paths for this op amp source. So there's a FET here which is fed from U42, and there's also this FET here which is fed from U41. So what I've done, I've actually pulled those two devices out of the board, or removed them both. That way there's no path to actually control either of those FETs, which means it can't have any influence on these parts, so unless those FETs are completely faulty, but that's unlikely. So I pulled both of those out and that didn't change anything, so I can eliminate basically all the top half of the circuit there too, which brings it down to this bit. So we're getting there. So I've been doing some more testing on here, trying to eliminate various sources of control. There's this voltage current converter here, well, voltage current converter rather, and I've tried probing around here and it seems to be adjusting roughly in line with frequency. Testing at that point there doesn't show any erratic jumps with the big steps in frequency, so things seem to be okay from this point. So I think I've eliminated that bit, which leaves me with this bit, which is getting better. That's just an input lock detector. I might pull that IC out if I can and just eliminate that in case it's got a fault. I've already replaced the various ICs and done swap arounds and stuff like that to see if anything changed, but nothing did. So I think it's an individual IC. So it really leads me to do more voltage checking on these two. Say if these look suspect to start with. I've already checked those diodes and stuff, but I'll pull that IC first, see if that changed anything, and then I'll go from there. So I was trying to probe a couple of these test points. 38, 39, which are those two transistors there on the bases. I've got them hooked up to my oscilloscope. I'm just trying to see the pulses, to make sure the pulses line up and look about right. And I'm stepping through the various frequencies and they're all staying okay. So you can see there, if I can get the glare off now. So that's, what frequency is that? That's 1 megahertz, 11 megahertz, and so on. 30, 40, 51, 81 where the step is, that's where the fault is. And that looks fine. Looks like the base into those two transistors is okay. If I keep going up, it's 91, well 101, it's 20 megahertz out, so 100, 110. Now getting to the point where it starts to unlock. There we go. Alright, so that's the unlocked. There we go, there's like noise on there, see it? So if I get the freeze spray, there we go. Get the thing to actually squirt, good. Yeah, fixed. So yes. So that noise is coming from all the way the other side of the board there. So testing here. Camera in my face. I've got the phone upside down from normal, so testing there, and that's that IC which is dodgy, which is causing that noise. So you can actually see the noise, so it's good. But apart from that, it looks okay. So although that's just unlocked, could just be my triggering. Starting to unlock again, so just spray a bit more in there. I can't spray very well from this angle, so okay, go up again. Yeah, that's right. So those look fine, the pulses at those points. which shows me this bit here is probably okay. I'm running out of ideas now then. Unless the pulses are just so subtly different that I can't see it on the scope. That's also possible. So I was going to measure the input of that op amp. No, the output's wrong. What's the input doing? Otherwise I'm getting a bit lost about what it could be. Well, I was going to do some more testing on this. I'll just show you this one. I'll turn channel 2 off because I'm not using it now. This is on the input to the op amp. So I've already been playing around with this a little bit. I was going to show you what it is. So this is currently doing about 50 millivolts division. I've actually got the probe set to one time, so let's just fix that. So it gives accurate readings. Oh, it's just the same voltage. Okay. I think I've got it on sometimes. Yeah, I've got it sometimes. Anyway. Odd. No, I've done that. Why am I working on channel 2? That's why I'm working on channel 2. Right. Because I turned channel 2 off. Right. This makes more sense. Now, so that's about 20 millivolts RMS. So I was going to look at the RMS value because it's a bit noisy. That's on 31 megahertz. 21 megahertz. Still 19 millivolts. 19.5. Go down a bit more to 11 megahertz. 19.1. So it seems to go by about 0.5. 0.4 to 0.5 step per 10 megahertz. So it's 19.5 there, which is 21, 19.9, nearly 20, 31, 20.5, 41, should be about 21, 51, should be about 21.4, 61. Okay, I'm getting 21.5, so that's kind of expected. And it says 81. Interesting. So the voltage going to the op amp is about correct, based on the step sizes at least. Frequency may be different. Let's just look at the actual frequencies here. I've got this set to a fine-tuned step rather than actual proper steps, just so I can get more on the screen. And that's saying 1 megahertz or thereabouts, jumping around slightly, as I'd expect, pretty much. So that's got 51. That's 1 megahertz still. 61, which is now showing 81. So this looks like it's actually in line with what it should be doing. There's nothing. That's where it unlocks. So we can ignore that bit. I know about that problem. So at the input of the op amp, it all looks normal. So that confuses me even more because the input looks okay. I want to think about this a bit more because this obviously doesn't work out right. Right, so I'll do some more measurements here, still on this U48 op amp, because the input looked okay but the output didn't really work. So this is interesting because you're expecting the track. So purple line, which is channel 2, is the output in SDC, and the input here, which is obviously pulsed, or frequency, 1 megahertz frequency going in. Yeah, that's obviously input, right? So they've got very different voltage levels. I'm just displaying both at once. You can actually see the ripple in the DC here as well, which goes in line with it. It's got some smoothing and stuff on it, which would be why it's doing that. So I'm currently at 1 megahertz, and the input is about 19 millivolts RMS. I'm going to say RMS voltages, not going to say anything about peak or anything. and the output is 10.9. If we go up to 11 megahertz, output is 11.2. Goes up about 0.25 of a volt each step on the output, each 10 megahertz step. And the input is 19.4, which goes about 0.4 to 0.5 millivolts. So, yeah, that's right, 0.4 to 0.5 millivolts it goes up by each 10 megahertz step. 20 megahertz, or 21 megahertz, it's 19.8 to 19.9, and it's 11.5. Again, it's just 0.25 step up. That looks normal so far. It's 31 megahertz, another 0.25 step up for the output, and what's that stepping up by? It's, yeah, about 0.4 step up on the input. So it's still tracking okay so far. 41 megahertz, again it's about another 0.4 up, and about 0.25 up on the output. So those are tracking in line with each other for each step, each 10 megahertz step. So 51, that's about 0.25 up again on the output. So that's now 12.3 or so. The 41 megahertz is 12.05, so that's, yeah, about the same. It's about 0.3, that one. And the input is about, again, 0.4. It's now 21.2. Go to 60 megahertz or 61. It's outputting 81. Let's go back to there, get that voltage again. 51. So that's 21.2 input, 12.3 output. It jumps by 20 megahertz or 30 megahertz, and that's 21.8 input, 13.3 output. So it's gained a volt on the output, and about 0.5 points, yeah, about 0.5 on the input, which doesn't equate to 3 steps. It only equates to one, well, just over 1 step. 12.2, 12.8, 12.9. It's about 0.6, 0.7. So it doesn't equate to the actual output step. And you see the frequencies look about right. You see some jitter there as it steps between them. Yeah, the output voltage increases a lot more than the input voltage does. I mean, it's amplified, but it's the actual step doesn't tally with what it's been doing. Which makes you wonder if it's actually an issue with that op amp, even though I have swapped it out. Pretty sure I swapped that one out. Or it's having backfeeding, which is also possible. So, so let's just look here. Zoom back out again. So I was measuring. What was I measuring? I've lost myself now. Here, right. So I was measuring pin 2 and pin 6, which is at test point 40. So you think that if the input is tracking, the output should also be tracking. It could be an external part here in the feedback, negative feedback loop. You know, there are capacitors, so it could be frequency dependent maybe. And it's got that plus VAR voltage supplied there, which is on the pin 7, which comes from over here, just there. It's got an 8.2 volt center there, and it comes from a 37 volt supply on that side. It actually measures 28 volts, which would be, you know, that minus that pretty much. So yeah, so I think that's okay. The negative supply is minus 15 volt with a 10 volt Zener, so that's minus 5 volts. That checks out okay as well. I'm actually going to do some tracking on the oscilloscope just to make sure those don't play up. It could be a digital control issue maybe, you know, because I'm sure I've already swapped that part out of another one to rule that out. So it must be something external to that chip, and there's not actually that much there that could affect that. Yeah, not much at all. Just a few external capacitors. Yeah, this is a bit of a pain to say the least, but I mean, it's possible something's back feeding from somewhere maybe, but there's this part here could possibly come back through. If I test point 43, that should confirm that or not. If that voltage here is differing more than this one, because it's got the resistor in line as well, so we'll see. So I just did a check on this at test point 43 and 40, just to compare the voltages using the oscilloscope as a reference, well, to view it rather than the meter. And there's about 0.4 volt difference between here and here, with this one being higher all the way through, and it stayed about the same difference right through until when it faulted. So I think it increased about 0.05 volt or something. So it's almost no difference. So it's not like a back feed from this end or something. So that rules that out. So yes, this is interesting. Something is not right here, I believe. This seems, the input seems to step correctly, the output doesn't. I still want to measure around these transistors yet. I'm not convinced they're okay. It looks like they've all been replaced, so, but I'm not going to say that they're alright. So I'm trying another approach right now. I pulled that op amp out. There we go, over there. That U48, I've taken it out. I've hooked on my variable power supply, just here, and there's the frequency up. So what I'm just doing is scrolling through the frequencies, well, manually using injected voltage, just to confirm that the output from that op amp will actually allow the whole frequency range to be scrolled through. So I've been just going through this really slowly. I can just show the lowest it will go down to. It'll actually go down really low and then it will come back up again where it loses lock or something. So yeah, about there is the lowest it will allow, and that's 10.79 volts. Come back again, I scroll up, and it goes up quite rapidly, you know. So, so 30 megahertz is 11.68, for example. So it's quite a narrow range on the output. I'm only doing like, was that 10 millivolt steps or something? So you can see it goes all the way up. No gaps, no jumping. It just does what it's supposed to do. Right, so. And that's, what's that, it's 15 volts now. Yeah, it's probably getting a bit high, so let's drop it down. So yeah, that's working like that. So it's not between the output of the op amp and further on. What I think I might need to do is inject before the op amp. Yeah, I don't know, I'm a bit confused by this part. Yeah, we'll see. We'll go through this and so yes, go from there out is fine. Using the op amp is not. I still scope those input voltages actually, I still want to do that. This and check out okay, but I mean these voltage input steps are absolutely tiny. So, my camera's coming loose. So because the steps are so tiny, maybe I couldn't detect them when I did measure those. Maybe I just need to re-measure those with the scope. I was using a voltmeter at the time, but I could see them, but it wasn't great. Maybe the steps weren't obvious enough on that. Yeah, I think I'm just going to go back to this point here and measure that. But yeah, I'm not sure. That input voltage seemed to look correct, whereas the output wasn't. I mean, how many things could it be? Could it be a dodgy diode here? Maybe under load it's changing? That's possible, I suppose, isn't it? That could change voltage under load. That's a consideration. Anyway, cool, we'll keep looking. Right, I'm still working on this, as you would expect. I'm just doing some more tracing. I just thought I'd just try and look at a different section. Hold on a second, let's get the diagrams. So, what I was just doing is I was studying the block diagrams. I was just trying to find other approaches because I haven't been able to determine what it is yet. So I was trying to at least narrow other things down. Let's get some light here. So I've obviously identified that this 800 MHz VCO is going out of whack. I know that's wrong. Okay. And that's run off a 10 MHz reference, which I already fixed. That's that fault, which I already corrected. Phase detector is what's controlling the 800 MHz VCO and the 40 MHz VCO. So I thought I'll just check this path out, and that goes back round that way. I was looking through here to try and determine whether any of this could be playing up. So I've hooked onto test point 11, and what I'm just trying to assess is whether the subsynth gate array is playing up, in case that is feeding back into it, because it is all one big loop. In case that's feeding back in and causing problems from here, and then the 800 MHz is trying to compensate. That's where I was kind of basically checking for to see if that's okay or not. Again, just trying to narrow down what it isn't rather than what it is. So here's the diagrams for it. This is the devices there as part of that is it clock generator and subsynth array, and the divide by 500. Yeah, divide by 500. This is what this is. Yeah, okay. This is the divide by 500 section. Well, that says 50 here. Interestingly. So anyway, that goes up here. Goes to checkpoint 11 or test point 11, which is where I'm hooked up to now. And it goes back into the low pass filters and feeds back into this quadrature detector and quadrature generator and so on. So I just want to check and see if the signal here is okay or not. So I've actually got two scopes hooked up. I've got that one there because it's good at showing glitches. It will show if something is glitching at all. And I've got the colours on and stuff on it, but I'll sort of put it again. Actually, I think it doesn't help. I've got persistence on as well, so it stays on the screen longer if it does glitch. Which is one of the handy little features of the scope. And I've also got my Tektronix running. Let's get the light off that. The only reason I'm actually using the Tektronix at all is because it's got a output on the back, channel 2 output. So the channel 2 goes in here, is buffered and amplified again, and then goes back out the back, and then you can feed that into a counter. That's how I really wish the Siglent had. If a Siglent had that output on the back, then I wouldn't need the Tektronix at all. I could actually, put it away as a spare. Always like to have spare stuff, but yeah. So that's the only reason I've got the Tektronix running as well. Because this has got a frequency display on it, but you can't trust it. It's actually not that accurate. One day I might actually pull this apart and upgrade it and make it a bit better. But so the Tektronix is running. I've just got it exaggerated on display. Do it the right way. I've got it exaggerated on display right now. I'm just trying to sort of look for anything which might show up. Well, I've got it hooked up to the top frequency counter. So that's what is at test point 11. And it should be 20 kilohertz. And you see how close that is, That's really, really good. That's the output of the generator right now. So I'm stepping down. If I zoom out a little bit, there you go. You can see that 20 kilohertz. Ignore that zeros. That's because it goes below the limit of that input. That input's got so it's supposed to be 100 megahertz input, and below that, so it's dropping off. But the all the way up, you can see that 20 kilohertz is stable, even when it's faulting on the output. So it's doing 20 kilohertz. If I just skim through like that, you can see it's just sitting there stable all the time, absolutely fine. And if I look on the scope, I'll do the same thing. You might see a couple of little glitches when it goes through some ranges where it steps, but I think generally it's pretty good. It's gone right down almost. There we go, see a little glitch there. Just there. Right at that point there. So between 250 and 240 it's doing that. And I know there is a range change just there. So I'm not too worried about that one. main thing I was trying to look for is if it's glitching when it's faulted. And those frequencies where it shows that little glitch up there, that's actually outputting the correct frequencies, so that's alright. So it's basically eliminated. Let's look at it again. It's eliminated this section here as being faulty, and interestingly this bit here, because that is fed from this 40 MHz VCO. Right now I'm actually leaning towards this divider being incorrect. So this one I tried to do that visual measurement on, but yeah, this is the one I'm leaning towards right now as causing the problem, but I'm not sure. So I need to be sure before I can actually get much further really. But so anyway, I know that this piece here is okay, because the frequency is okay, the scope looks good, so I'm confident that bit's okay there. So this section here I believe is okay. I've done some measurements here at this 40 MHz earlier on, because it's got a 20 MHz clock generator, and the fact it's out by 20 MHz was making me think, hey, is that a coincidence or not? Could there be a problem there? There still could be, but it's just, I need to do. I think I might do some more programming in this section just to rule this out completely. But I'm fairly confident it's okay. About the time I was only looking at frequency, I wasn't using the scope, so I might go back and actually revisit that with the scope and just make sure that what's coming out of here is okay. That's all part of what I was trying to track down. I mean, this is obviously a simplified overview. What I'm actually doing is look at the electronics diagrams and trying to do it from that. But so, and there's that gate array at U17, which I'm suspecting, just there. You see, it's all interrelated, and all the bands are wrong. So let's see, this band here is wrong. This band here is wrong. It doesn't actually mention the lower band. So I don't think it's just like anything in this section, because that all seems to be the same across all the bands. It's doing the same fault right across that 20 MHz shift. It's not changing by much or anything. So actually there was a point I did see a 10 MHz offset. I did mention it earlier on. So maybe that is related. If it's halving, because there's a divide by 2 here. So it might have been that band I saw that 10 MHz difference. That's possible, isn't it? Certainly is possible. Anyway. So that's that VCO there. That's that VCO output. The main VCO. So yes, I was thinking about that 800 MHz VCO thing. And this is the actual 800 MHz VCO just here. So I can't measure 800 MHz directly on my scope, but it's got a divide by 4, which is right here. And there you go. Now this is actually a 100 MHz scope, but I can read 200 on it just fine, so that's quite good. My Tetronics does 300 anyway, but yeah, nice on this one. So that shows that 800 MHz is there. Now I've tried stepping through the actual frequencies where the error occurs, and that doesn't change at all. It's still rock solid. So that 800 MHz there isn't an issue. So at least that rules that bit out. Right, so I've just measured these test points here, 24 and 25, for this frequency here. So it's 40 MHz coming in, it's divided by 2, applies flip-flop, some buffering, and then it goes into this sub-synthesizer. I measured both of those, and they both measure 20 MHz, and they're both stable and don't play up at all when it's glitching. Or 14 we want to call it. So here looks okay. So I don't think this sub-synthesizer is a problem. At least doesn't appear to be. Right, so let's measure in the synthesizer output. So obviously I've measured here. Now I'm going to measure the output of that U33. It's supposed to be between 10 and 19.9975 MHz. I'm not quite sure what the distinguishing factor is between those, because all I'm actually getting out is 10 MHz all the time, all the way through. So I'm not sure about that. I might have to do some reading It might just be modulation related, but it doesn't seem to be band related. I've gone all the way through from 1 megahertz up to 441 and it stays at 10 megahertz all the way through. And seeing it's some kind of divider, unless it's looking for some minor steps. Let's see if I can try it actually. Let's do minor steps. Let's oh, there we go. Right, so I've just changed the step size. So okay, that's what it's doing there. That solves that question. So I've just changed it down to we're doing smaller steps anyway. This is put into a range. I think you see it. Yeah, 51 megahertz. See it stick it there. So yeah, if I'm doing smaller steps, then it shifts there. You can see the frequency at the top there, hopefully, although it seems to be a bit glitchy. I don't know. I might have to look at that in a different way. Very ringy, but yeah, so at least that is actually changing that. This is 15, 10 there again. I've got a persistence on this, so it's probably not helping much. 10 again. So yeah, it seems that depending on what step I've got in the front here, if I can get it on the camera. There you go. So this I'm just stepping as those, so you can see it there. I've got that 1 second persistence on the scopes. So let's try another digit. Yeah, so that's what that's for. That's for doing the minor steps, not the big steps. That shows it quite well actually, doesn't it? See some shadowing on there. Anyway. Yeah, that must be what it's for. So it's something that Synthesizer's doing the smaller steps. So I'm confident that that part is okay. So if I don't change it, only change the big steps, the frequency stays constant even when the unit is given the wrong frequency. So I'm 99.9% sure that this bit is alright. Okay. So eventually I'm going to eliminate everything and I'll be going, what the hell? Anyway, so we shall carry on. Okay, just had an idea. I remember I've seen that the frequency is often out by 20 megahertz, at least on the lower band. And I remember I'd seen it being out by 10 megahertz. I thought I'd just go through the frequencies again. Now I've got a bit more of an idea of what I should be looking for, knowing about the other flip-flop which has failed, which is causing unlock. So I can ignore that section of the issue. So I was trying to find out where the 10 megahertz error was coming from. So I was going through the bands and I thought, right, well, the 800 megahertz VCO here, that's just for a mixing signal. That's all it does, right? It's a fixed 800 megahertz. It turns off when it's not needed. So if I come in here a bit more, when you're on between 245 and 1 gig, well 1.05 gig, it goes straight through, right? If you're on anything other than that, it comes through this mixer, and so anything up to 245 megahertz comes through this way. Alright, so I know that's okay. I know I'm getting the error here, which means it must be coming from this way. Alright, the error is coming from this path. So this path comes from two sources. Right, the 245 to 512 and the 512 to 1050. I know that one there, that the upper one, is definitely giving an error, right? So I wanted to go through the 245 to 512, and that's what I've just done, right? And I found an error. So I'm currently on, there you go, it's 320 megahertz, 330 megahertz. That's out by 10. Right, so that's that 10 error. Now I've got it on 340, you can see it's glitching, which is probably that PO unlock. Then 360 is okay, 360 error again. Should be 370 there. So that's, yeah, see there's errors there. It's probably that P will unlock. Actually, I'll just confirm that. Okay, let's get my spray. Let's give it a squirt. So I'm currently on 370. So it's likely to be that unlocked there, right? I get the thing to come out. Yeah, almost. Didn't get it very well. Right, there we go. So yeah, that's that faulty flip-flop there, right? 360, 350, yeah, 310, 320, 330, 340, 50 unlocking, 60 okay, 70. So, and there's that glitch there as well. So it's on that other band as well. I'm wondering if maybe just replacing that part is going to fix the whole bloody thing, you know? I'm starting to wonder that. I've been looking at this thing the whole way. We'll see. I mean, I've ordered the parts. I've ordered them from, I think, 3 different places. So, whichever one gets here first will be the one I can put in there. But yes, that's interesting because the, yeah, so at least that's 10 megahertz out, which is half as much error. Which gives me a clue, which means it's being divided by 2 somewhere. That might help me. Anyway, can I look at the diagrams? So, just looking at this, that's the main VCR, which I know is wrong. That's all that the circuit I was probing before here. There's a VCR clamp and stuff like that. So that's where the VCR output is error. I know that every VCR is wrong. So here we go, divide by 2 right there. Okay, so that means the fault has to be before that VCO, as I'm suspecting anyway. So that just confirms what I've been suspecting. So I know that after this point's fine, after that point is fine, because the only common thing is from that VCO and all this leading circuitry. So my colour shift keeps going off. It's on auto, it's on automatic and everything anyway. So you've got phase detector here, which I am suspicious of. Very suspicious of. I think this low pass filter and stuff, yeah, so that's the notch filters. I know the errors before there. And that's that other clamp which I've actually disabled and stuff and played with, and open detector, yeah, ignore those. So in here I am very close. This is the other parts I've disabled, so I've ignored all this stuff. That can all be ignored. I've ruled that out. But by putting the ICs out, I did a video I did a few ago. Well, probably part of the same video I'm doing now. Earlier in the video. Phase detector is where it seems to come back to. Or this U17 gate array. Because this phase detector is detecting those 1 megahertz there and the 1 megahertz from here. So I'm trying to figure this out. This is derived from the reference, remember rightly. There we go, over here. I've got the high stability reference in here, so it comes straight through, it switches over. If it detects the signal, it switches automatically. I've already confirmed that correct. Comes through here, buffers and shit like that. All this is okay. I've already confirmed all that's right. It's one of the first things I'll fix on this thing. Divide by 10 to get 1 megahertz. I know that's okay, so that phase detector signal that side is perfect. Which narrows it down a lot, so it's either this phase detector or something in here. So just in this bit of the circuit is where that fault is. I'm leaning towards this part here, that U17, because if that's not dividing correctly, then it won't. It will tell the phase detector to will allow the wrong frequency for the phase detector to compensate for. I'm actually wondering if what I need to do is actually try injecting another signal somehow. I might just look at this and see if there's actually a way of injecting a signal to disable parts of the circuit to eliminate it. That's what I'm looking at right now. And you saw me inject a voltage here before, to manually control the VCO, and that will work fine. So was it just after there? Yeah, after that point it's right there. You test point 40. So I injected the voltage there, and that controlled the VCO fine. So I know that from there outwards is okay. So it has to be before this point, and there's not much there. So yeah, I'm concerned. But I'm going to have to look at this and see if I can find a way of injecting a signal in here. A stable enough signal, which is precise enough to work. Yeah, that's what I'm going to have to try and figure out next. Oh, this is complicated stuff, but great fun. So I'm starting to probe around this end divider here, just to try and determine what's happening in this section, since I do suspect this is part of the problem. So I either want to prove it or otherwise. So I'm currently probing on pin 15 over here, which is there. Which is I think it's an output. It doesn't actually say very clearly, but I believe it's the data input into this flip-flop here. I think that's what it's doing there. Okay, so I think it is actually an output. This is mode L and C mod, I think it says, or O mod, I'm not quite sure. Anyway, I've got it hooked up to the scope. I'm currently on 100 kilohertz, and you're getting one little pulse. Right, so I have to adjust the trigger, and you probably see error and stuff. And if I go to 200 kilohertz, you get a bit more, 300, 400. Okay, let's keep on going up, and you'll see the pulses increase. And then I'm just going to scroll it through right now, just holding it down. Let's get a bit closer. See the pulse. So you start off by getting more pulses, and then they change value. Triggering is not right now, so let's just scroll it. Right, so that's what we're now getting. So they gradually go up. So initially it increases the pulses, and once it's saturated with the number of pulses, because you look at the frequency there, it doesn't actually change. Here, come on, here. Right, so that's 1 megahertz there. See, that's maximum. So I'm just trying to determine whether things are working as they should be. Right, so what I'll do now, I'll go too far. Ooh, pushing buttons. Hold on a second. Let's get this right. Okay, so once it saturates, then it moves up scale. So that shifts up, goes up. That's what we're on now, 40 megahertz. So I'm doing 10 megahertz steps now, but then it steps down again, then up again, up, down, up, down. So these, based on the step sizes I've got, so that's 10, 20, 30, 40, so 50 goes back down the bottom again. That should be 60, 40, 50, 60 should be slightly higher, but it's going to 80. That's doing 90, that's doing 80 again. Alright, so based on those values there, and the way that is the pulses are reacting, I believe that is doing the right thing, because it's all in line with what I should be doing for each step, which makes me a little bit more confident about this part. Now I've also got a probe 16, which is the input to this, I believe it is. Anyway, so I think it's TTO output from this device here, U20, which is actually fairly warm, it's quite warm. But that one there, let's change the scope probe around. So this is a very noisy output. I'm not quite sure if it's just my triggering is a bit dodgy or what, but it looks like it's got lots of jitter on there. So if I do this, let's see. So I'm on, let's start 10 megahertz, right? So 10 megahertz there. You can see the actual timing is changing each way. It's blurring each side. I've got persistence turned on, so it will do 1 second persistence. So the middle is looking right, but each end is off, which means the timing is changing. If I go to 20 megahertz, again same thing. 30 megahertz, same thing. 40, slightly better, but still the same. See, 50, now it gets really bad there, and that's when it's faulted. So what I think that is noise from the VCO coming through. That's the best one there, and that is on 80 megahertz and actually doing 80 megahertz. Whereas that's 80 megahertz, well 60 megahertz and actually doing 80 megahertz. So they should be the same in theory, right? If it is a control fault, it's not, is it? So that's the same frequency, 80 megahertz there, 80 megahertz there. The noisy one's the errored one. Which brings me back to here. And part of that circuit is this U18, here we go, U18, right? Which is this one here, which I know is faulty, that one there. So it could just be that all that noise and stuff is from this particular chip and that will go away. But the fact that noise is increasing when it's errored versus when it's given a correct one, that's a good sign. Because I've actually seen something which is different now. So it does make me wonder now if this particular chip, which I know has got a fault, is what's causing the entire fault. Maybe it's not just causing the 2 faults identified, maybe it's causing 3 faults, which is including that 20 megahertz offset. That's what I'm wondering now. So I've actually found something positive from that. So I might just have to just keep probing around and see what I can see. But I imagine if this, I think it's a clock input based on the labelling, CKNL and ICKL. So I'm guessing that's a clock input, which this then divides down in order to give the 1 megahertz output. But this makes me wonder, eh? Because I mean, that's showing, is that 21 megahertz coming in? Yeah, 21 megahertz. So it could just be some ringing in the circuit, but I'm not sure. It looks like a frequency error, jittering frequency. So if that's got to take 21 megahertz in, divide that down, 1 megahertz, that's divided by 21, isn't it? So I was actually thinking as well, if this chip has failed, and I can determine what frequency comes in, what frequency's got to come out, and that's the digital input there, I could probably write to an Arduino, maybe, it depends on the frequency steps, stuff like that. I might be able to write a little microcontroller with the Arduino. Arduino's what I know, there's probably other stuff which is better for it, but to actually replace this chip, I could take that signal in, divide it down based on this data coming in here, and spit a signal out, you know, using PWM or something. But maybe PWM, maybe digital addition, you know, binary addition or something on the outputs. That's also possible. But anyway, I've got these inputs here which I haven't even looked at yet. I don't know what the hell they are. I haven't traced those yet. But I thought I'll just look at what I know. This is the 800 megahertz. Well, sorry, the high band VCO. So that's the, what's that? 0.49 gigahertz to 1.05 gigahertz from main VCO, right? Which I know is the one which is noisy and jittery when it's got that fault, and the and steps by that 20 megahertz amount. So I know this is coming in wrong. It's coming out wrong, but that is a loop, right? So it goes back out, it goes to the phase setter, which then controls the VCO. But if there's a fault in here, it could cause this to possibly divide incorrectly, so it outputs the wrong frequency, which then makes that wrong, and so on. So, you know, but that is pulses coming out of there, and you can see it's actually got a bit of ringing in there and stuff. But I probably don't have that deal set up for this. But yes, this is making me wonder about that chip there. Eh? You know, it might not just be that. This U20 is also quite hot. So there's a bit of warmth in that. I might actually look to see if I can find a replacement for that, but what does it say? MC12013. Yeah, never heard of it. So I don't like my chances of getting a replacement. And unfortunately, it's not in a socket unlike a lot of the other ones. Probably because it's got a higher frequency going to it, so they don't want to reduce the ringing and stuff going to it. But which means I have to cut it off the board and replace it with another one. And it might be pointless anyway. Yeah, so I've actually found something, at least something which correlates with the error I'm seeing, which is great because it means it's not, I know the error is showing up here. Whether that's just coming in from here, that's the next thing I should look at. I should look at that actually, see if I can figure that out. We'll see, but it's definitely, you know, that's pin at 16. That's 16 noise. That's, you know, something at least, you know. But then I think it tracks back to this oscillator here. Right, that'll do for now. Right, so now those parts have arrived, I can actually put them in. I'm only going to do one thing at a time. I've got various parts in case I needed them because I wasn't sure about them. So we've got the main one, which I know is this one here, the MC10131, which I know is fried because it doesn't react right. Shouldn't be able to spray it a little bit of freeze spray and have it completely change profile on how it works. So this can come out. Now I'm going to try the AliExpress version first, because out of all the ones I've purchased, these are the ones which are most likely to give problem. So I'd rather rule those out. But they look like old stock, so I think they're okay. They're dated 85, and the Future ones are dated, was it 81, was it? Oh yeah, 81. So, oh, I'll close these pins up. So I'll pop that in there, then I'll plug in the power. And I'll chuck the scope on there. Yeah, they've got some slight corrosion on the top of those pins, so yeah, it's definitely old stock, not a copy. Let's pop this up. Power things up and see if it actually works. Let's see what's backing up. Let's see what I can see from here. Probably not enough. Well, it's currently sitting at 80 megahertz. What I want to look at is the noise on that pin, on that test point I found before. Was it 16 or not? Just there. That was very noisy before certain points. And 80 as well. Over that. That's working. That looks like it solved that. Oh, I was speaking too soon or not? Oh no. Yeah. Okay, so changing that chip to solve the other issue I had as well, which is why I stopped working on it. I did a couple of videos troubleshooting trying to find the 20 megahertz offset which it had. Trying to trace that down. And the closest I found was noise on this pin 16. This is it's test point 16 just here. I had lots of noise there, which is fed partially by this IC I just changed here, the MC10131. So it's fed from that, in that area. It's all like linked together, part of the face to feed and everything. And I was starting to suspect that maybe that chip was playing a part in a 20 megahertz offset. This is a perfect 20 megahertz, which it may be one if it's a digital control anyway. So I stopped working on it, thinking that maybe it is this chip as well, not just that jittering I was getting. The other test I've got to do is change Fluke counter inputs. Let's chop this down. So 10 MHz. So the other test I've got to do is go right down to trying to get the camera work right. Right down to as low as it will go. So, because at the bottom end is playing up. Right now it's all working fine. Yep, down to 10 kHz. That's it. It's working. Cool. It's actually behaving the way it's supposed to, which is brilliant. It's going to scan up through the frequencies all the way up to the top, 1 MHz at a time. Interesting. There's a little bit just there, which wasn't there just now. There we go, 90, 91, there we go. That's not working there. Issues. Okay, so there's still some problem here. So, 176. Make sure we can get both in this picture at the same time, actually. No, I can't off from here. So, right, 177, 178, so it's jittering around. So there's still an issue there, but it's narrowed it right down. So, that one's about 176, that's when I find out the limit. Something else weird, I didn't see 160s before. Yeah, around there, here you go. 198, 199 is not right either. That's out, that's now it's doing 151. The scope's looking okay. So there is another fault somewhere, which really doesn't surprise me. Oh, I know what it could be. Yeah. Silly me, I might be fine. I'm at the top end of my Fluke counter on that range, so it's back to 170. This one's only rated up to 120 MHz on that input there. It could be that frequency's topping out. Let's do that. This makes much more sense. Here we go, that's fine. That's okay. Oh, there's something just there. 242, 243, 244, 245, 246. I'm sure it's all saying there just now. It's been a counter rounding or something. I'm just going to go through those ones again. Because it's rounding down slightly, so it makes it a little bit hard. It flicks down to 9s, so it might be okay. Could have been the way it just appeared. Right. Well, it's looking pretty good so far. It could take a little while though. When you get to about 512, might be some rounding going on. Hold on. When you get to about 512, I think there's another step. Yeah, that's right. Just that frequency rounding. The 512 is not a step, and it might be a problem there. 11, 12, 13. Cool, that's looking alright. So now I might go up in 10 MHz steps on it. That's a bit harder to keep an eye on. That's it. The whole frequency range works. It looks like I might have solved it. Take off. Right. So that's the culprit right there. So this one I see here was responsible for 3 faults. The bottom end not working below, I think it was below 20 megahertz, I think it was, it played up, and the very bottom, I think it's about 10 kilohertz to 40 kilohertz not working, and the 20 megahertz / 10 megahertz offset on certain channels. So that's the fault to watch out for. If you get that, then this chip is something worth looking at. If there's some further testing, that seems to basically be working. And see if there's any other faults which I can find. Right, so I've got my spectrum analyzer running. I've got it hooked up to that. I've got a 0 dBm signal coming out of the Fluke. So that's going to go right down to the bottom. I've got a span starting at, start frequency of 1 megahertz, finishing 1100 megahertz. So you should be able to see it sweep right through around that line at the top. And I'll do a similar thing for different output levels just to prove they're okay. So, right, starting now. I'm going by 10 megahertz at a time. There's a couple of glitches where you'll see it changes ranges on the Fluke, so you see a glitch. All the way through. Sweet. No funny jumping around with me. So let's just change the amplitude. Let's go to dB. Let's go down. Let's see, let's do, as you can see each step is going right, so that's 0 dB minus 10, yeah, minus 20, minus 30, minus 40, minus 50, minus 60, minus 70 disappears. So I'm going to do a quite low level, that's minus 50 dBm, show the lighting's catching it. Go back to frequency again. And I'll go back down the range again, turns. If you just to test the attenuator stuff out. So there is a little bit of variation there, but again, because of the span, it's not going to be scanned perfectly. See that little glitch just there? That's the changeover at 245 megahertz. You can see there. So that's nothing. So yeah, all the way through. Sweet. So that's actually looking pretty good. The only thing I've got to do now is modulation tests. That's the only thing that comes to mind, at least. And we'll go from here. Oh, so I've got this spun around so you can see it. I'm just sitting on 80 megahertz. That's what I'm going to leave it on. I've got minus 10 dBm output. I've got this plugged straight into my spoon time modulation meter. I've got it set to 30% mod AM, 1 kilohertz. that's what it's giving. If I switch it to 400 Hertz instead, that's still the same, doesn't change, which is good. I prefer 1 kHz test tones myself, but let's see. What do we want? AM modulation. Let's change this level, so I might go all the way up from 99. So that's 99. I'll go 90, 80, 70, 60, 50, 40, 30, 20, 10. Right, so it's not too far off. I mean, I don't know which unit is out of calibration, whether it's my boom time, which is a bit out, whether it's the Fluke, which is out. Obviously there's a bit of an error there, but it's not a huge error. I think the worst is 50%, it's out by about 10%. Everything else is slightly better than that. So yeah, that's not too bad. So I'll do FM modulation, turn AM off. This is a good question. It's not percentages. Percentage of what? FM. Oh, that's interesting. I hadn't considered that. That's interesting. Well, let's do 5 kHz. Thought that would work, but it doesn't. I should figure out how to use this, but that'd be fun, wouldn't it? I thought that would work. Oh, here we go. I'll push the right button. That button there. FM. Right. It's very dim, but you can see it there. Kilohertz deviation just there. I might actually see if I can increase the voltage going to this display, make it slightly brighter. So it's set on 5 kHz, and that's what I'm getting. Let's step this over. Let's go up by kilohertz at a time, 10. Okay. 15. 20. 25. 30. It's bang on there. 40. Also bang on. Let's go up by 10s. 50. 60. 70. 80. 90 kilohertz. Yeah, it's pretty close. So what I'll do is I'll just go 2.5, just do that, 2.5 kilohertz. Get the light off it and get a sit. 2.7, just do 10 divided. So it's pretty close. So the modulation appears to be okay. Let's go 400 hertz. Yeah, still fine. So it works. You can actually do AM, FM at the same time, which is really interesting. I've never seen that before. He doesn't seem to like that. Right. So, yes. So I do AM only. I'd be confused by that because I'm that one still. Yeah. Interesting, so you can do AM and FM at the same time, and the boom time handles it. So let's see what I was going to show you. This test point here, I originally used it on this scope here, and you can see the frequency jitter. There's a bit there, like phase noise or something in there. Interesting. So yeah, it's still there, but yeah, it's not jumping all over the place now. It's consistent at least. So it must just be the way that actually works, because I can't fault that. I can't find out where that phase noise comes from, but it is actually reduced quite a lot since I changed the IC. So at least. So frequency range is working, modulation is working, levels are working. I haven't tried doing any saving and recording memories. I don't know how to do that yet. Let's have a look. Let's just try this. 26.5 megahertz. It's a nice channel. store that where? I don't know how to use this. Don't know. I have to figure that bit out. But anyway, the rest of it seems to work. I have to see how the memory stuff works. So it looks like I've actually fixed it. What I'm going to do on here, it's got the RF output, which is obviously on the back with the modulation input, which is one of the options for this, which is set by this switch just here. Number 4. That was actually turned off. It's supposed to be on when it's got the rear output, so someone's obviously messed with it. It's also got the the black pen on it. So someone's obviously marked that for some reason, obviously when they're playing with it. So I'll turn it back on. All it does is it compensates a little bit for the RF level drop on here. But in saying that, when I was looking at my spectrum analyzer, it's actually, I've got a 0 dBm output on it at the time, and I was getting around 1 dB in some cases. So it might be it doesn't actually need a compensation turned on in this case. Anyway, what I'm going to do, I'm going to open up this port on the front. I've ordered some sockets. I'm going to keep the original all intact because it's got this hard coax on most of the back. It runs down there. From the front, it comes out at this point, just here. So what I'm going to do, you can see where the socket goes just down there. I've ordered some SMA cable and a jack to go in there. I'm just going to unplug this, put the jack on, and run a little SMA cable between the two. And it's only going to be a few inches long, so I'm not too worried about any losses or anything like that from it, or shielding problems. I'm just going to do that because obviously I'd like to get the hard coax one, but came with it, but chance of getting that is almost impossible. So that should do the job anyway. And then I'll give me the output on the front, which I prefer. I might move the modulation input as well to the front as well. That would make sense, but that's going to be fairly simple. It's just a BNC, so no problem there.